Hi, welcome to the Physionic podcast, which is now, you could say, has become the annual Physionic podcast because the last episode was about a year ago. So I planned on doing these every 3 months or so, but as you can see, that didn't end up panning out. And I'm not putting myself under too much pressure on this podcast simply because I've got other aspects of Physionic that I have to focus on. But that said, I do have a number of topics that I'd like to discuss with you today. And for those of you that put on the podcast to fall asleep, then rejoice. You have more material to fall asleep to. Speaking to that, assuming that YouTube allows me, I'm going to turn off the ads like I usually do throughout the podcast. So hopefully you won't be interrupted with any sort of, annoying advertisements throughout. But if not, then I apologize. YouTube makes a lot of different changes to ad policy over time, so we'll see. Anyway, at any rate, if you'd like to listen to the podcast, so aside from just watching it, just to be clear, there's nothing going to be on screen. This is a purely, perfectly raw video of me just talking to the camera. I'm probably just going to be relaxing on my couch on this extremely gloomy Sunday that I have behind me. So I thought it would just be the perfect opportunity to discuss some science, get into some of your commentary. I got some really good comments, some good pushback, as well as some questions that people brought up on the topics that we're going to be covering. And speaking to that, last time I think I covered every single topic that I'd covered before or after the last podcast. I can't do that this time because I think I've released maybe 70 or 80 different investigations, different videos, different analyses since the last podcast. So it is, actually probably more than that, probably closer to well over 100. So there's no way I'm going to be sitting here. Although the previous podcasts were, 3 hours, 5 hours long, there's no way that I'm going to be sitting here and talking for like 3 days. So I've picked out specific topics I think are especially useful or interesting and things that I wanted to discuss, and I think that you'll hopefully find interesting as well. If you're one of those people that believes that a person should just get to the point, I've probably already dragged on too long on that front. So first of all, I think those individuals don't understand what a podcast means. But the second thing I can say is that I will supply links under the video so that you can click on the link and then go to a much shortened version of what I'm going to be discussing. But you will miss out on some of the commentary that I'm going to be covering, because one of the benefits is that with the comments that I can retrospectively go back and kind of highlight the top comments that people have liked a lot. So they rise to the top, and then I can discuss those under each topic. Okay, well, with that, I don't know if I mentioned it already because I had to redo this introduction 2 times already. There is a link to the podcast. It's completely free. You can just click on the link and, sign up through Spotify or Apple Podcasts or whatever you like to use. Just be sure to know that it's not a weekly podcast. It's not a monthly podcast. It's not even at this point a quarterly podcast. It's just really whenever I feel or have the chance to sit down and do these extended stays. But that said, let's get into it a little bit. I've got my notes here. So we're going to dive into, I'd say maybe 7 or so topics, maybe a bit more, and also go over your commentary. All right, so the first topic is collagen on skin. So this is a topic that I've covered a number of times at this point. When I initially covered it, I had come to the conclusion that the collagen studies that had released on skin had indicated a benefit of consuming collagen peptides on reversing skin wrinkling, improving skin hydration, improving skin elasticity, things of that nature. And that was maybe a year ago, and I think I covered that in one of the previous podcast episodes. However, then there was this new analysis that released this year in 2025, maybe a few months ago, wherein the researchers in their overall conclusion said, yes, collagen peptides seem to be effective for improving skin and all the different metrics that I had mentioned. However, what they also did, what was unique about that analysis, that meta-analysis, and I think they went over maybe 20 or so studies, 28 studies, 24 studies, something along those lines. All of them were randomized controlled trials. And what they did is they divided the studies based off a funding source, as well as the quality of evidence, as in for meta-analyses, what they'll do is they'll go through a Cochrane risk of bias assessment, so a ROB scale, or they'll go through a grade scale. And they're very similar to one another, and there's different versions of these different scales, but it's essentially a standardized system by which the researchers go through question by question of, is the study double blind? Is the study randomized? Is the study, there's a bunch of different questions that they have to answer for every single study that they include into the analysis. And then they give each study a score. I think it's a 3-point score. So they usually either get a red ticker, a yellow ticker, or a green ticker. Green meaning low risk of bias, red meaning high risk of bias. And if you're thinking yellow is moderate risk of bias, you might be able to call it that, but it's really more so unknown risk of bias. And like I said, there's different iterations of this. So they ended up breaking up the studies based off of the funding source, if it was industry funded, so funded by, let's say, a collagen company or a skin company, and by the quality. So was it low risk of bias in all these different questions? And what they ended up showing after you got over the overall conclusion is that this analysis indicated that when you broke things up by those standards, that the studies that were industry funded indicated that there was benefit of collagen peptides on skin, and the studies that were not industry funded or industry affiliated, so they had independent funding, maybe by like a university or some sort of internal funding for that institution, that they would show no benefit or largely no benefit of collagen peptides on skin. So on the surface of it, you'd think, okay, well, then that's pretty clear. It's, I've always been on this side of, I'm not going to dismiss a study simply because it's industry funded. But now that we actually have evidence at this point of, okay, well, the non-industry funded studies indicate that there's no benefit, I'm going to side with those studies over the industry funded studies, if you actually have that comparison. However, when you open up the analysis and go further into the details of that analysis, you look, so for a lot of these meta-analyses, they'll list all the studies, and then they'll tell you, it's basically a big table of with the studies on the left side, and then a bunch of different, information like the study length, the participants' age, the participants' weight, all these different factors, get put into a table, so it's just easy to read, so you don't have to open up each individual study. And at the very end of this table, they had put the funding source, and then they had also put the outcome. So what happened when collagen peptides were compared against placebo? And I ended up looking at all of the non-industry funded studies. So the ones that they had said that if you pool all that data together, that you don't see a benefit of collagen peptides. And 6 out of 7 of the studies, there were 7 studies total, 6 out of 7 of those studies indicated a benefit of collagen peptides on skin. Only 1 study showed no effect. So that's probably pretty confusing to you, because you're thinking, well, hold on, you just said that the non-industry funded studies showed no effect and the industry funded studies showed an effect. And now I'm saying the opposite. So what's with the ping-ponging? Well, the answer is because the researchers, and what researchers do is that they speak in very scientific terms, as in they use this type of language that is, if you're not in the field, it's difficult to interpret, and it can be misleading. We'll just put it that way, simply because they say there was no result. I'm paraphrasing, obviously. There was no result, but what they actually meant was that there's no statistically significant result. But then when you actually look at the data, look at the grouped data, you notice that, the reason why there's no statistically significant result is because they don't have enough power in the analysis to detect an effect, which means that they don't have enough data included in the analysis to detect an effect. And so to break that down further, what I mean by that is if we had 28 studies total, industry funded and non-industry funded, we have 28 studies. That's a lot of data. But then once you create this subgroup analysis where you break it up by funding, meaning we've got this group of industry funded studies. So if that's 28 minus 7, that would be 21. Hopefully I did my math right. So that's 21 studies for the industry funded, and they do show an effect. Then you have 7 studies for the non-industry funded, and they don't show an effect. Now the question is, well, is it because there's truly no effect, or is it because you don't have enough data to detect an effect? And it turns out that the answer is probably the latter. And the reason for that is because if you look at each one of those studies, 6 out of 7 do show an effect of collagen peptides on skin. So if you were to look at the individual studies, you'd be like, oh yeah, for sure, collagen peptides are effective for skin. But when you group that data together and then you apply meta-analytical statistical analyses to it, so doing a bunch of mathematics to it, then you have to consider the certainty of the evidence. And because you've shrunk the pool of data from 28 studies to 7 studies, the certainty of the data becomes a lot less certain. So that ultimately yields a situation where you have to report it in scientific speak as no statistically significant effect of collagen peptides on skin. And that's kind of where we landed. So you can run with that and say, oh, okay, well, then there's no effect of collagen peptides in the real world on skin. Or you can say, oh, we just need more data to be input into this to really detect an effect. And if we were to just look at the individual studies, we would actually see an effect, because you'd be 6 versus 1 indicating effectiveness. So some people didn't do that part of the study analysis, and therefore, in my opinion, came to the wrong conclusion. But I could easily see, an argument for a person wanting to be exactly by the letter of the law. The statistical significance did not indicate, any effect. I will say for a lot of these subgroup analyses, they do kind of like subgroup analyses where they look at the non-industry funded studies and then they cross-examine those with the quality of the evidence. Remember the Robb scale that I was talking about, the grade scale that I was talking about. And then you're taking the 7 studies that you have, which is already a small pool of studies in this situation, and you're cutting it down to even fewer studies. Now you're looking at like 2 studies or 1 study and trying to make a meta-analytical conclusion based off of that, 1 study or 2 studies. And then you're shrinking the amount of data that you have even further. So, you could make an argument either way. If you're a purist and you just want to go by statistical significance, then you would say, yes, or I guess I'll say no, there's no effect of collagen peptides on skin. If you are a person who's a little more flexible when looking at data, which I tend to be, I think I'm kind of in the middle between like, oh, that's a joke to just look at statistical significance, and the more strict people that are saying only look at statistical significance. I'm kind of in the middle there, but if you are more flexible in that way, then you would say, oh, okay, well, there's probably an effect here. We just don't have the data. We don't have enough data to really detect that effect. And I will say for some of the subgroup analyses, it got very close, even though there was very little data, again, relatively speaking. So then there were two critiques that I addressed as well. One was that collagen peptides are never compared against protein. And I think that's an excellent critique. That's true that in none of the studies that I've looked at, I don't think any of the studies that were included in this analysis, do they compare against protein. And that's problematic because it's possible that it's not the collagen peptides themselves, but it's once they're hydrolyzed. So you consume collagen peptides, meaning that they're in these 2 and 3 amino acids that are stitched together, as in they're molecularly bound to one another. So they're still together, as opposed to single amino acids, which is what you think of like for glycine or methionine or leucine or whatnot. But in this situation, they're still stitched together as these di or tripeptides. And the argument for the protein perspective is that, well, if you just consume enough protein of those amino acids that make up collagen, then you will no longer see an effect of collagen peptides, we'll call it a unique effect of collagen peptides. And that's a perfectly fair argument to make. And I don't have a great rebuttal against that, simply because we don't have that evidence, except for I think one burn study. So people that were burned had like 2nd degree or 3rd degree burns or something along those lines, and they were randomized to be given collagen peptides, or they were randomized to be given protein, and the collagen peptides did see an improvement in their skin recovery over the protein condition. But that was a single study, and I don't remember off the top of my head, but there were a few things that, kind of like what we're talking about, like I wish they had done this kind of situation. So I don't want to base the entire pushback against the protein argument simply based off of this single study. I think that there's a lot more that we need to see. So I think that's up in the air. It's certainly a possibility. I will say that mechanistically, there has been evidence where the collagen peptides themselves have had an effect on cells. And I even covered a study which I recently discovered on collagen peptides versus a protein in an in vitro, so on cells. And I covered this a little bit for the insider version of my analysis on what we're talking about here, skin. But ultimately, they showed that there was a unique effect of collagen peptides over protein. So, there's a smidge of evidence that pushes back against this protein idea, but I just don't think that it's strong enough yet to really dismiss that idea. So from a skin perspective, yes, I think that we need comparisons to really tease out if there's a unique effect. That's really what the question we're trying to get to, or trying to answer. Is there a unique effect of collagen peptides? Because if I can do the same with just consuming more protein or a particular type of amino acid or whatever, I'd probably prefer to do that than to go with the collagen themselves, simply because collagen is probably going to be an added expense on top of, protein, which is much more readily available. The other pushback that I sort of thought about in my own head that I don't really hear all that often, but I still think of it as a decent pushback is, well, shouldn't 7 studies be enough to detect an effect? And I think I've got a twofold answer to that. One is that even though 6 out of 7 studies show an effect, I don't think I've ever claimed that collagen peptides are going to turn you, I think in my video I said, from Al Pacino now to Al Pacino back in like Scarface or The Godfather. It's not going to dial back time by 50 years or anything like that. What it's going to do is lead to some mild improvements in skin elasticity, hydration, and wrinkling and whatnot, and maybe has a protective effect over time as well in mitigating some of that as the aging process occurs. So it's a mild effect. I've always said that it's a mild effect. But, for some people, having that mild effect is important. So, the other aspect, other than just looking at the effect size, is the overall time horizon for a lot of these studies. So we're looking at, 12 weeks, 8 weeks, maybe 16 weeks, which isn't no time. But, when you're thinking about reversing some signs of aging and whatnot, it's possible that we might see greater effects. And if all 6 studies that showed an effect in the non-industry funded studies, if all 6 of those studies had lasted for like 3 years or a year or something along those lines, maybe the effect size would be large enough that we would be able to tease out some of those differences. I realize I'm getting a bit technical here. I'm kind of giving myself some leeway for this podcast. Maybe I'm banking on the people that are going to fall asleep to this, helping them out by getting into some of those technicalities. But the main point here to take away is that collagen peptides seem to be, based on this analysis as well as others, seem to be effective for improving your skin. It's a mild effect. Don't expect anything completely transformative or anything, but it will have a mild effect on your skin, and that seems to be consistent, definitely in industry-funded studies, but there's even a signal in non-industry funded studies. I think that's where I would leave that. Okay. Actually, that's not where I'm going to leave things, because I've got 2 more things to discuss. I've repeated this many times, but people will bring up, well, what about the mechanism? How does that make any sense? Why can't I just eat more protein? Which, by the way, on the protein front, one more thing I will quick add is that it doesn't make a whole lot of sense to me to try to equate the protein to collagen. So here we are. I was thinking I was going to just give you takeaways, and those takeaways are accurate, but I'm going to be talking about this for a little bit longer because I just had another few ideas. So if in a study, you would typically want to equate the amount of protein to the amount of collagen that you consume. So if you're consuming an additional, let's say 15 grams of hydrolyzed collagen, and then you would want in the control condition to be consuming 15 additional grams of a protein, right? To compare, because if you're consuming 100 more grams of protein, well, that's kind of unfair. So to actually tease out that unique effect. And in that situation, it seems unlikely to me, I mean, maybe you disagree, but it seems unlikely to me that 10 or 15 more grams of protein is suddenly going to lead to these positive skin effects. 10 to 15 grams of protein in the grand scheme of things isn't a whole lot. So I find it unlikely that we would see any sort of similarity between the collagen and the protein. But the main critique that people will say is that it's the components of the collagen, so like the glycine and the proline and whatnot, that are leading to these collagen producing cells, fibroblasts, chondrocytes. But in this situation, we're talking about fibroblasts, that these cells take up these amino acids and then they use them to produce more collagen. So we might as well just consume more proteins that have these amino acids, and then they'll also still be given the requisite amino acids to then produce collagen. And that's fine, but that's not actually the argument for collagen. The collagen peptides that get absorbed, and they do get absorbed, that's another question I get asked. And we have human evidence indicating that people who consume collagen peptides, or not necessarily collagen peptides, but peptides of dual amino acids and triple amino acids still bound together, they do end up in the bloodstream. So that for sure we know. It's not just single amino acids that get into the bloodstream. Then the second thing is, well, then once they're in the bloodstream, are they just taken up by the cells to be then produced into collagen? And the argument by a lot of like cell biologists and people that know physiology will say, well, those cells will then probably take up, even if they did take up the dipeptides and the tripeptides, they would then break them up. So they would still end up as single amino acids within the cells. And there's some truth to that. I mean, I'm not disagreeing, but the real argument is that it's not actually what happens inside the cell. It's actually what happens on the surface of the cell, because we've discovered that there are multiple collagen peptide receptors on the surface of the cell. And if that's the case, then the collagen peptides actually interact with the cell surface to the cell collagen receptor. And then that leads to a change in the signaling within the cell. So it's not the actual components of the collagen peptide that lead to more collagen peptide production, because now you have more of the building blocks, but it's the actual binding which convinces the cell to produce more mature collagen fibers, which get deposited into the skin layer. That's kind of the idea. Now, I will admit that I don't think that we have foolproof evidence that this is exactly how it works, mainly because the reviews that I know of, and when I opened up a lot of the studies, what they show is that these receptors bind to already present collagen fibers. Is it possible that the collagen peptides could interact with these receptors and cause similar benefits? Yeah, it is. But my whole overall point is that there's a lot of unknowns that we're still trying to tease out. But so far, the evidence still seems to be leaning towards collagen peptides having a unique effect. And that may, one day shift completely to the other side. So for those people that are like, well, doc, people say one thing one day, then they say something else for another day. That's because everything I'm explaining here, this thought process of like, here's where the evidence, what we know, here's what we're kind of speculating, but there's a few little gaps here that we need to figure out. Here's what we don't know anything about. This is the kind of thought process that scientists have to go through just to give an intellectually honest answer. So once we start plugging in more of that information, once we start discovering some more of that information, it could very much shift to a more complete answer that ultimately leads to an opposite conclusion. And that's why the field grows, right? Science grows. That's why the whole idea of things developing over time. It's just, unfortunately, social media is does not lead to a environment where people can explain a lot of those nuances. It's just everybody wants the information basically injected into their brain or transmitted. If you speak for just a second too long, then you immediately get hit with complaints of, well, this was too long, you just get to the point, all that stuff. So you get caught between these two areas of like, this is the level of explanation. So if I were to be talking with you, one-on-one, this is how I'd be explaining it to you. I'd first open the conversation by saying, how much time do you have? And if it's an elevator pitch, I'll be like, there's a lot of holes in the research that we still need to figure out, but so far the evidence leans to collagen peptides being a benefit for your skin. Have a great day. But then if a person's like, I want to know everything there is to know about the certainty of the evidence and just like explain the mechanisms and explain the physiology, explain the data, like what the clinical trials show, talk to me about the funding sources, we would be here for however long it's been. I don't know the time because my camera is all the way over there. But yeah, it's been about half an hour. I'm seeing by my recorder here. So it would be that level of discussion for me to explain where we are. And who's going to sit here except for you, poor soul, listening to me ramble on my couch about collagen? Very few people. So you're just a special person. So yeah, that's why I'm saying social media is going to seem like it's flip-flopping. And another aspect is there are some people that are just grifting, bottom line. Okay, so that all said, I wanted to cover some comments like I did last few podcasts. I do enjoy this. Hopefully people feel like they're being heard. Again, I'm picking among the top comments under some of these videos. So Burnham's Ghost, that's the name of the commenter, said, as a case study, I can say this. I've had 5 knee surgeries, 2 ACL reconstructions. Just as a side note, wow, that's a lot. Speedy recovery, that's a lot. Maybe a player of some sort. I don't know. Maybe getting up there in age, maybe a combination of the two. Anyway, continuing. Increasing knee pain over the decades, especially after military service. Okay, well, there's your explanation. Over the decades, I tried everything and nothing really allowed or showed promise until I started taking collagen. I was able to start running again, and when pain does emerge, it subsides much more quickly than before. I think I'm less likely to be a victim of the placebo effect in this case because I've tried so many things and started out as very skeptical. Yeah, so this is obviously anecdote, but and this was highly bumped up by people, but that's certainly a possibility. Like I said, and I'll say this, and I've said this in the past, that the scientific literature can sometimes be pretty far behind the anecdotes that come out. So people will try something and they'll experience significant benefit from that. But then when you look in the scientific literature, there's almost no data or no good data on that topic. So does that mean that thing doesn't work? No, it doesn't. But that said, you're also kind of caught between a rock and a hard place because you also can't say that all anecdotes are accurate, right? And as a matter of fact, I would probably say the majority aren't. Simply because, exactly what Burnham's Ghost said, that there's a placebo effect, but then there's also like many other things that a person might change at the same time. So it's more correlational than it is causative. There's a lot of different factors. So kind of hard to tease out, but based on this person's experience, and they're talking primarily for joint health and improving, from surgery recovery and whatnot. And I do have topics. I have looked at collagen on joint health, which actually wasn't quite as strong as it was for skin. But even so, this person is saying things that align, their anecdote aligns with what some of the research indicates. I think that the benefits they're experiencing are probably far more than mild benefits, though. Okay, Astrolab had said, one thing I noticed on these studies is that they span a short time. Okay, for example, your joints, you notice that the benefits aren't great, but for someone suffering with osteoarthritis, which is degenerative and with no cure, it's an awesome result to have less pain after a year rather than more pain. Same with wrinkles. Maybe the effects compound over time, and after 3 years, you are 1 year younger rather than 3 years older, which is still great. And that's absolutely true. So if we had studies that lasted for longer periods of time, we'd be able to, that effect slowly grows over time, or at least it could. It has the potential to grow over time. And we can try to project that outwards. We can try to estimate that outwards, but that doesn't actually mean that we've collected the data to show that that's actually the case. And yeah, so that's true. And the thing is, though, you're probably not going to get studies that are going to last 3 years on like collagen and skin, or collagen and even your joints. simply because it's very expensive, and they're going to use really sensitive metrics to try to tease out if there's an effect. And once they find an effect, they're going to cut the study's going to end. And when they don't need a whole year or multiple years to detect an effect, why run a study and spend hundreds of thousands more dollars just to end up at the same conclusion? Although, admittedly, on then social media, people will say, well, they've got this critique and whatnot. And some of those critiques are absolutely fair. It's just that researchers can't go to the NIH or they can't go to their funding agency and be like, hey, so we could detect an effect in 12 weeks, but it's going to be a really small effect. So we'd really love to find a really big effect because we want to know what happens over many years. So would you mind floating us a couple $1 million more just so we can say that there's a bigger effect than there was? Usually that's not going to fly. That's not enough of a reason to spend millions of dollars. So time is a huge factor when it comes to studies, especially randomized controlled trials, but we're unfortunately not going to get those data. Okay, I think I've sufficiently rambled on enough about collagen and skin. Let's get into another interesting topic to me, one that actually wasn't that popular, but I wanted to cover it anyway because, well, I'm just going to allow myself to be a bit selfish here. That's ketones having a relationship with worse liver health. And the way I framed this initially was to point out that, yes, there was a study that showed a relationship between higher blood ketone levels and worse liver health. So that's a relationship, that's an association, that's a correlation. But what it doesn't tell us is if the ketones are causing this poor liver health or if it's the poor liver health that the ketones are actually trying to help with, or if something else is going on here. It just shows us a simple association of ketones and liver health. However, what the researchers ended up doing was they generated mice that had a inability to produce ketones, and then they measured their liver health when they taxed these mice to have worse liver health. And what they showed is that the mice that were still able to produce ketones had dramatically diminished liver fattiness and liver damage and liver fibrosis and just overall worse liver health. While the mice that had ketone production blocked, known as ketogenesis, they had far worse liver health, as in they had more fatty deposits in the liver, more fibrosis, et cetera, et cetera. So the takeaway from this was that the excess ketone production is not a negative. It's actually quite the opposite. It's almost like a release valve for the liver, because if you're not aware, the liver is where ketones are produced. So the liver is producing ketones to essentially try to tamp down any sort of fat accumulation inside of the liver. So think of like fatty liver disease. So the ketones are a way to take the fat droplets or the fat molecules that would be stored in fat droplets within the liver cells, the hepatocytes, and have them flux through the mitochondrion and the powerhouse of the cell. And the mitochondrion will then convert those fatty acids to ketones and then eject them back out of the cell. So, and the liver cell has a number of different ways that it can try to deal with these fat molecules that would otherwise accumulate in the liver cell. So it can package them into LDL particles and then eject them out of the liver. It can metabolize them, so it can use them for energy, but it can only do that up to a certain amount because the cell only needs a certain amount of energy, and at a certain point it's just not going to need any more. Or because the liver has this ability, it can produce ketones. So once you knock one of those systems out, the ketone production, then it has to rely on the two other systems that it has. And this is speculation on my part. And that's what ultimately leads to a lot of stress that it could occur in the liver if you don't have ketogenesis available. So ketogenesis in that scenario indicates a protective effect of the liver. Okay, so then I took it a step further because this is all in animal models, trying to figure out mechanisms of how ketones are protective and all that good stuff. And that's great. However, then I was interested in obviously the human research, and the human research pretty dramatically shows that low carb diets, fasting, whatever, however you want to increase your ketone levels, because a very low carbohydrate diet like a ketogenic diet and fasting are two of the most potent ways of increasing your ketone production, and both of them lead to significant improvements in liver health. So, and there's probably some nuances there that I need to get into in more depth, but overall, both of those were great ways of reducing fat that's surrounded and inside of the liver. So I thought that was just such a cool study to try to figure out how ketone production, and that's a key point there, is it's not the ketones themselves, although maybe ketones have additional benefits, but the study was really trying to tease out what does the production of ketones, so the actual metabolic flux that has to occur for those ketones to be produced, how does that impact liver health? And that seems to be a positive. So that association that we were talking about earlier, or that I was rambling about earlier, is that the most likely, as liver health is getting worse, the ketone production is increasing because it's trying to, again, eliminate as much of that fatty liver disease as possible. However, that doesn't necessarily mean that it can actually deal with that poor liver health. So, ultimately they're both going to track together, as in ketone levels get higher and higher as liver health gets worse and worse. But it's like the body constantly trying to compensate, and it just can't keep up with the worsening of the liver health. Also, I just want to be clear, just because you have high ketones doesn't mean that you have bad liver health. Because again, it's just an association. One may be causing the other, but it's not the ketones that are causing the poor liver health, or at least not based on this research. So anyway, just a fascinating study that I thought I'd share. Now, a few comments. Robert Stanton said, in 2019, I was diagnosed with non-alcoholic fatty liver disease with NASH, which is non-alcoholic steatosis, steatotic hepatitis. Nope. I'm going to struggle with that one, but it's another type of liver disease. Steatotic is, I think that's the S in there, but I can't remember the H. It's just fallen right out of my head. And F3, F4 fibrosis. By changing to a ketogenic diet, I completely reversed my liver disease, and according to the latest FibroScan report, my liver is now normal. That's all I need to know. That's what Robert said. So first off, Robert, you're probably not listening to this, but first of all, that's amazing. That's genuinely incredible. I mean, it's incredible at any point to have such advanced levels of liver disease or any sort of disease, and then to be able to change your routine or change your nutrition or something along those lines, and then to see such significant benefits that fight against this disease state. So, and that takes a lot of willpower, and it takes a lot of I'm going to change something about myself, and that in its own right, just on a human level, without any of the scientific garbage, is an incredible feat. So huge congrats to you. The only other thing I'll say, well, actually two things. One is obviously that's, again, very much in line with what the research indicates. The other thing that I will say is that I get this, I get a lot of these comments from people that say, and that's all I need to know. And on one hand, I shouldn't say completely. On one hand, I agree. But on the other hand, there's a tug inside of me that's like, unfortunately, I think that mentality ends up pushing into other areas of scientific communication or nutrition and whatnot. And we end up, I don't know how to phrase this exactly. We end up discounting scientific evidence simply because something has happened a certain way to us. So I'll give you an example using this exact situation. So if I use a low carb diet or let's say I use fasting and I reverse my fatty liver disease, and then I say something along the lines of, well, that's all I need to know. I know fasting is the end all be all for me. It's not always the case, but oftentimes people will then get so focused on this one thing and they say, well, this is the thing that worked for me, so therefore it is the thing that will work for everyone. And that's not necessarily the case, because a person could try like a Mediterranean diet, for example, so something completely different, and get the same results. And those both can be true. So you can have one thing that is really impactful and really helped you as an individual, but that doesn't mean that other things can't help. And I'm not isolating Robert here, just to be clear. But just the overall thought process, just because I see these kinds of comments all the time, especially if people will use it as a refutation of the evidence at hand. So if there's a study that says, low carb diet is better than a Mediterranean diet for, let's stick with the theme of reversing liver disease. And then a person who's been using a Mediterranean diet, is like, well, I used the Mediterranean diet and it worked really well for me. It works. I tried a low carb diet. It did not work for me, but a Mediterranean diet, that did work for me. And that's all I need to know. Like, that's fine. I mean, nobody's disagreeing with you on that, but it's not a refutation of the science. It's like, there are many things that can be true, and it's really difficult to communicate that stuff again in short videos, like punchy videos that are trying to get to the overall point within a reasonable amount of time. Very much, again, I'll just crap on this podcast again, unlike what I'm doing right now, which I'm sure I'll get comments on. Anyway, the big point here, though, Robert, is really fantastic. I'm really happy for you, genuinely. And keep it up. I hope that it stays that way. I can't imagine that it wouldn't. But yeah, keep it up. The next one is from James Sales. I'll move on. In my N of 1 research, so anecdote again, I resolved my non-alcoholic fatty liver disease with ketogenic and carnivore-ish diet and lost 48 pounds in 6 months. This is confirmed by MRI imaging and AST, ALT, and GGT lab results. Thanks for the video. So first off, thanks, James. Secondly, again, just like with Robert, huge congratulations. That's no easy feat, especially losing 48 pounds as well over 6 months. That's really fantastic work. James is talking about for AST, ALT, and GGT. Those are enzymes that are secreted out of the liver when it is being harmed. So when there's harm occurring to the liver. And so if you see a reduction in them, that means that the liver is in a better situation. And also confirmed by MRI imaging, as mentioned. So again, that's fantastic. And again, if we look at the scientific literature, if you drop 48 pounds, or if you just drop weight in general, you will typically see improvements in your liver markers. You will see improvements in your liver. So it's not like a person has to prescribe themselves to a very specific diet, because just because we're discussing right now, we're talking about low carb diets, we're talking about fasting and whatnot, and how those are beneficial for liver health. That doesn't mean that there aren't better ways or different ways, or maybe not quite as effective ways, but still sustained, like they're better for you as an individual to use. There's a lot of different ways to attack something like that. And especially when you are pairing that with weight loss, it's a little bit different. Maybe when a person is not trying to lose weight, they're trying to maintain their weight or even gain weight, but still maintain proper liver health or improve their liver health. But if you're losing weight, that almost necessitates improvements in your liver health. So just something that I would add. If a ketogenic or carnivore style nutrition works for you, that's great. There are obviously, certain other considerations that people have to consider. I'm not going to go down that rabbit hole for the time being, but the point being, and the overall point of my video and my analysis and whatnot, is that low carb diets and fasting can certainly be an improvement, and a significant improvement for liver health. So for both, really great, and I'm genuinely happy for you. All right, the next topic is to cover drowning cancer in a fatty molecule, butyrate, in this situation. So I covered this fascinating study, probably one of the most fascinating of the year up to now, which essentially looked at the impact that a short chain fat called butyrate, has on cancer, specifically colon cancer. And what they showed is that butyrate can not only inhibit the growth of colon cancer, but can kill colon cancer as well. And I won't go into all the details, but there's, mast cell death to the colon cancer, that while sparing healthy colon cells, so colon being your large intestine. And so if we were to look at a person's colon, probably not the most desirable thing, but we're going to do it anyway. So you have your intestinal tract. Maybe if you had an image of the intestines, if you were to zoom into the intestines, and then you notice that there are these crypts, these kind of grooves that create this like snake-like look almost. They look like caverns that go into the intestinal wall and then come back out, and they actually make up the intestinal wall. And inside those grooves, at the very bottom of that groove, you have a bunch of stem cells. And these stem cells end up multiplying and turning into a variety of different intestinal cells, if that's Paneth cells or goblet cells or colonocytes of other, general colonocytes. There's a number of different cells that they can turn into, but they ultimately give the intestine structure, right? And the intestine has a number of different functions that, again, we don't really need to get into, but it's at that exact site. So at the very bottom of that crypt, that these stem cells, if they undergo mutation burden, or if you believe more of a metabolic environment, that ultimately leads to more of a cancerous type of cell that starts getting born. And then that stem cell that is now more cancerous starts to multiply. So you start to get a tumor, or you start to get growth in that region that is abnormal growth. And that's obviously why we get colonoscopies, because we start to detect some of those abnormal growths that start to occur, and we try to catch those early. Okay, so why are we talking about that in relation to butyrate? Well, the reason is because as we consume foods that ultimately get produced into butyrate, that butyrate can get into those crypts and can be taken up by the cells. And when they're taken up by the cells, according to this research, the cells end up kind of freezing, like they can't grow anymore. And in the worst scenarios, they end up dying. And the reason for that is because the cancer cells, at least the specific ones that were tested, the cancer cells are using sugar or carbohydrate as energy, and they are less able or less willing, kind of use those interchangeably, because we're getting to the limit of my knowledge on the topic at this point, to use fat molecules. So because they're using sugar, they're using carbohydrates, and I just want to be clear here, I'm not using the word sugar as in like Pepsi or whatever, although that is also included in this definition. I'm talking about sugar as carbohydrates, glucose specifically. And carbohydrates are made of largely glucose. So when glucose enters inside this cancer cell, it gets metabolized into cellular energy, as well as many other things that, again, we don't need to get into. But butyrate, because it's a fat, can enter into the cancer cell. And because the cancer cell is not going to take that butyrate and produce it into energy, it starts to accumulate inside of the cancer cell. And because this butyrate it has no destination, it's just being taken up into the cancer cell, because the cancer cell would normally, if it were a normal cell, would be taking up butyrate for energy production. This concentration of butyrate outside the cell allows butyrate into the cell, and it starts to build up inside the cancer cell. Now, from there, butyrate has a number of different mechanisms that it affects the cancer cell. So one of the main ones that was detailed was the fact that it probably, we don't know if it's direct or indirect, but it probably has some sort of interaction with key enzymes called HDACs, or histone deacetylases, and as well as histone acetyltransferases. And what these two types of enzymes, these families of enzymes, do is they add or remove a particular type of tag to the DNA structures within our nucleus. Within the cell has a nucleus where all your DNA, all your genes are kept, and there's these different structures within that nucleus that keep DNA and genes, we'll say, organized. And the proteins that control that organization of the DNA and the genes are these histone deacetylases and these acetylase enzymes. So they'll add what are known as acetyl groups or acetyl tags to these different structures, and that will change the organization of the genes within the nucleus. Okay, so why does that matter? Well, it matters because if the cancer cell is trying to bind or close particular genes, so if it's trying to bind and express or lead to more production of particular proteins, it has to have access to particular genes that allow for the production of these proteins. Think of like pro-growth proteins. And what butyrate does is it will close those genes so that the cancer cell can't access its own genetic information. So it cannot produce more of those pro-growth proteins. The other side of it is that it can open up the genes that are anti-cancerous and can lead to cell death, which cancer has a number of different ways that it can stop cell death, because obviously it doesn't want cell death. Why would it? It's cancer. So it's trying to grow as rapidly as possible. And when I say it's trying or it's doing or all that stuff, just know that cancer cells aren't thinking about this stuff. I'm just kind of speaking in a little bit more plain language, even though it may not seem like it. So just know that the cancer is just reacting biochemically in a certain particular way. So in this situation, the butyrate could be opening the genes that are anti-cancerous. And a perfect example of that would be, I don't know if I discussed that. Maybe I discussed this in the insider analysis. Doesn't matter. They may produce more of particular proteins called BCL proteins. These BCL proteins will essentially allow mitochondria to die. And if you have mass mitochondrial death, then the cell destabilizes and ultimately you get cell death. So butyrate encourages a lot of the anti-cancer genes to be produced into proteins, and it cuts down or shrinks, closes up, makes it more difficult for cancer cells to access the pro-cancerous genes, or the genes that would be more attributed to cell growth. So that's the mechanism by which butyrate functions. Now, in addition to that, the concentration gradient, if we go back to this crypt, so again, the intestinal crypt, at the bottom of the crypt, there's lower butyrate levels. At the top of the crypt, there tends to be higher butyrate concentration. And the idea behind that is that the butyrate can also have a dual function in that it can also encourage the production of more healthy colonocytes, healthy intestinal cells, while at the same time inhibiting the cancer cells that would otherwise be growing in that region. There's a lot more that, especially some nuances like the different types of cancer. I don't want to jump to the conclusion that this would apply to all cancers. We do have evidence that butyrate helps against other cancers as well, but what this study focused on was specifically colon cancer. And there's certainly more intricacies to the topic than just, I'm going to up my butyrate and then therefore I'll be cured of colon cancer. I don't want that to be the message. But there's no doubt that there is a growing body of literature, which is already pretty steadfast, saying that butyrate will at least help fight against colon cancer. So I thought that study was really remarkable, and especially when they dove into the different mechanisms and the different concentration gradients and started getting into all those details. I thought it was really, really incredible. In terms of how can you increase your butyrate levels, I guess I'll quick mention. So you can take, like some people were saying, well, I'll just eat more butter because that has butyrate in it. And as far as I'm understanding, that is true. So there are many foods that contain butyrate, and especially fatty foods that contain butyrate. The problem with that is that you might be, I don't know what the expression is, but you're stealing from the piper to pay the pauper or something along those lines. The point is that there are consequences. So in some situations with particular foods, like, you might be increasing your butyrate concentration, but then you're also increasing the concentration of many other molecules that you may not want. And as an example, for butter, you might be increasing like stearic acid or palmitic acid, which are two saturated fats. Butyrate is also a saturated fat, but butyrate has been consistently linked to a lot of positive effects, while stearic acid, and definitely, I'll say at least palmitic acid, has been linked to more negative health outcomes. So, you could get butyrate from other sources, And I kept, seeing that comment, well, then I'll just eat more of butter or I'll eat more of this other thing. And I mean, yes, like technically, yes, that would increase butyrate, but you also have to consider the other consequences that come with that, the other molecules. You're not just producing butyrate, or you're not just consuming butyrate plus other beneficial molecules. You're consuming butyrate, which is beneficial, plus some potentially detrimental molecules. So there's a lot to say there, and having an analysis on each single food is completely overwhelming. So the most direct way to get butyrate other than supplementation is to consume fibrous foods. And I've said this many times before, but fibrous foods get taken up by microbes, and those get converted to these different short chain fats. And it is true that not all of the short chain fats that get produced are necessarily butyrate, but it doesn't really matter because many of the other short chain fats show benefit on our health. So even if it's not butyrate specifically, you are going to be increasing other molecules alongside with butyrate that also have positive health effects, unlike what we just talked about. So fiber, and not to mention that fiber has a consistent association. I actually covered that recently as well, that fiber has a consistent association with improvements in cancer, so preventing cancer across a number of different cancers. And this has been repeated across many, many different studies. So we have a strong basis of literature indicating that fiber, and we know that fiber gets converted to butyrate, and we know that butyrate has these positive effects, not just in this study, but other studies as well. So that's why I'm focusing on fiber as opposed to other sources of butyrate, which may also come with undesired other molecules. Okay, let's get into some comments. And I remember I had one comment that strongly disagreed with what I presented, so I wanted to cover that one at least to the best of my ability here. All right, the first comment is from Bill Davidson. He said, "My father always told me to eat lots of garlic and onions. I always thought it was to attract the ladies, but now I know the real reason. Thanks." Because I'd mentioned high doses, not cooking doses, but actual like much higher doses of garlic and onion have been shown to increase butyrate levels. So I will say, Bill, I'm not sure who would have said garlic and onions was going to attract the ladies, but either way, I'm glad that the video and finding sources of butyrate is going to be an overall benefit to you. Thanks for the comment. Another comment that I received, which was quite lengthy, so bear with me, was from Wellington Amaral, PhD. So a PhD of some sort. I don't know in what field, maybe this field, who knows. But he wrote a few comments. So one, legumes and roots. So this is from Wellington. I'm going to abbreviate as Wellington. From Wellington, legumes and roots like beans and potatoes, when cooked, and you don't want to eat them uncooked, are high glycemic, so glycemic index. The glucose from these foods will overpower the effect of the fat metabolism in cancer. I'm going to come back to address these comments in just a second. I'm going to go through them, and then I'll read what I responded, and then I'll maybe add in a little bit more commentary. Number 2, butyrate produced by bacteria is produced in fairly low amounts, even among people who host ideal gut bacteria to produce it, plus a lot of it will be consumed by the gut cells. Number 3, in cancer consuming and thriving in fats, so in cancers consuming fats, because there are cancers that take up fats, these are experiments done in a dish and usually where the cells are soaked in insulin. which is commonly added in vitro cell culture. So in vitro meaning the cells are in a dish. So that the cells survive in a dish. So Wellington is saying that the researchers add insulin to cancer cells. Even though these cancer cells use fat for energy, they're given insulin to help them survive in a dish. Enough insulin and the cells, even cancer cells, will feed on anything, really anything. Number 4, just to be clear, there's 7 of these. Number 4, there's another molecule that is very similar to butyrate produced by gut bacteria that doesn't depend on fiber. That's beta-hydroxybutyrate produced in the liver from, they wrote fast metabolism. Fat or fasting metabolism will produce beta-hydroxybutyrate. So I'll just adapt and add a little bit to that. It can be produced in much larger amounts in the body and will reach the cancer wherever it is. Number 5, beta-hydroxybutyrate is also produced through dietary manipulation, so ketogenic diet. So it's a high-fat, low glycemic carb, moderate protein, or prolonged fasting, usually over a day or two for most people. And there are some fats that are more easily processed by the liver into beta-hydroxybutyrate, like MCT, so medium-chain triglycerides, from coconut oil, for instance. Number 6, there is a concept or calculation that can be easily done at home based on the ratio of glucose to ketone as an index, so the GKI. That's the glucose ketone index. That can indicate the range or ratio where beta-hydroxybutyrate is likely having a therapeutic effect on cancer in a living human body. Beta-hydroxybutyrate is one of the 3 ketone bodies produced from fat metabolism. And finally, the Warburg effect, to explain that, well, okay, actually he explains it, so I'll read what he says. Warburg effect explains that cells shift their metabolism into fermentation compared to regular cells because of faulty mitochondrial oxidative metabolism. I mean, I'm going to pause right there because I'm having flashbacks to when I was 23 trying to understand some of these words. So what the Warburg effect is describing, which was discovered over 100 years ago at this point, is that cancer cells, many cancer cells, will prefer using glucose or sugar. Remember my definition of sugar from before, for energy and for other reasons, again, that I won't go into for the time being, because they don't or can't use fat for energy because their mitochondria are somehow defunct. So therefore, they strongly prefer using glucose, sugar, over fat. And that's what he's talking about. Mitochondrial oxidative metabolism is the fat metabolism, and fermentation is the glucose metabolism. Hence why cancer cells, going back to what he said, hence why cancer cells are so hungry for sugar, glucose, and why they're so good at grabbing it from the blood before healthy cells. There are amino acids from proteins that are also fermentable, like glutamine, among others. It's in every food, and one can't just not eat it. Hence, there's a suggestion that blocking cancer's use of these fermentable amino acids pharmaceutically in conjunction with a generic diet may be necessary to kill cancer cells. But patient populations see at least temporary, a few years, delay or regression in cancer progression just in a well-designed mentioned diet. So talking about ketogenic diet. There are more factors to be considered, but this is enough, probably too much for a comment. No, I thought that was really great, and I'm glad you're very thoughtful about it. Look up ketosis. Definitely well aware of ketosis, considering I described it in my material. And cancer research by Dr. Thomas Seyfried, Dominic D'Agostino, and others will come up in the search. Sorry for the interruption, Doc. This should render material for at least a couple more videos. That's certainly true. Have fun with it, and nice work on the educational videos. So thank you. First of all, thank you. I really appreciate it. I'm very well aware of Dr. Seyfried's research as well as Dr. D'Agostino's research. I actually met Dr. D'Agostino briefly earlier this year in person at a conference. But so I'm going to go through my response, and then I'm going to add in a few details because I thought that there were several things in the comment that were incorrect. And I did double check a lot of this stuff just to make sure that I wasn't, spewing BS. So my response to Wellington was, well, thanks for the comments, Wellington. I'm puzzled by some of them, though, which I was. For example, legumes are not high glycemic. They're not. I suppose you could argue that they are compared to fats, but that's not actually how the glycemic index or the glycemic load are compared. Glycemic index is speaking to carbohydrates, so not talking about fats. I'm also confused on your points about low butyrate production by ideal bacteria, considering that the majority of our butyrate comes from the microbiome. And then I looked up some numbers around 50 to 100 micromole per day. Millimole per day. That's a big difference. It's true that we absorb less, but even so, the amount consumed to absorb is consistently linked to have a biological effect, especially around the liver and the portal vein, because that's the first point of interaction for whatever is absorbed by the body from the intestines. I actually have more videos releasing on that soon, so I do have more. I did have another one coming out on butyrate, so that was on the immune system. Not sure I agree on all cancer research being done in dishes where cancer cells are soaked in insulin. In fact, I know that from firsthand experience, considering that I worked with cancer cells and didn't use insulin. Here's an example of fat-consuming cancer cells not exposed to insulin. It includes an in vivo research. It even shows beta-hydroxybutyrate signaling cancer growth, and then I supplied a study number. I agree about beta-hydroxybutyrate. I have content on that too. I'm also familiar with Dr. Seyfried's work. I have a video on his work and plan on doing some others, time permitting. I definitely need to cover that more extensively. I think his work is intriguing and seems to have some great arguments, but it also doesn't account for many other considerations brought up by the cancer research community. Anyway, I plan on covering more on the ketogenic diet and cancer in the future. It's a fascinating area of research, and I wish I could get more into it and flesh it out more. Yeah, again, thanks for the comment. Again, I don't actually agree with some of the comments here. And I've heard almost all of them before from other people. The point being that while we focus so much on cancer research and just this idea that all cancers just use glucose and that they have a complete inability to shift to fat metabolism, that hasn't been what I've seen in the lab when I was doing my PhD, because actually initially I was doing some metabolism work, and I ended up doing some metabolism work, but I was doing some metabolism work where I had switched cancer cells to using more fat metabolism. And it is true that they didn't grow nearly as quickly, nearly as well, but that also doesn't mean that they ended up dying off when switched over to fat. Now, it is true also that I did not restrict. So part of Dr. Seyfried's ideas, as far as I understand it, is that you would restrict glucose to the cancer cells, but in addition to that, you would also restrict their glutamine, which is what Amaral Wellington mentioned, that you use a pharmaceutical to stop glutamine in the mitochondrion, and you also stop the cancer cells from being able to rely on glucose, and therefore it stresses them to such a degree, because they can't use fat in this instance, that they end up dying. And there is when I did do a video on this maybe 2 years ago, a year and a half ago, and I covered some of the aspects of Dr. Seyfried's work. I went through multiple of his reviews and some of his papers and whatnot. And then I also presented the other counter argument. And in that, I brought up that there are studies looking at cancer cells that prefer to use fat metabolism. And I'm not sure. I think Dr. Seyfried may have changed his stance just slightly, just shifted it. Don't quote me on this. But my understanding is that I know for a fact that there are cancers that do only, or I shouldn't say only, primarily use fat metabolism to sustain themselves. That doesn't mean that there aren't many cancers that use glucose for energy. Now, the exact reason for that is, I think, debated and again, I just need to preface this, I need to look more into that literature. I have looked into it some. There's arguments that it is a mutation burden, as in the cells are unable to produce the requisite enzymes or whatever it might be to shift over to fat metabolism. Or that there's damage or morphological changes that happen within mitochondria. And Dr. Seyfried offers some images. When you look at some of the mitochondria, the inside of the mitochondria, called the cristae, is either damaged, like completely havoc has been wreaked on the inside of the mitochondria, or it just doesn't exist. Which speaks to the potential effect that metabolism could have in these cancer cells. So there's a ton to say here. I just don't think that I would boil it down to as simply as, well, people just need to jump on a ketogenic diet and restrict their glutamine, potentially through pharmaceutical means. That would probably be the only way. And then you'll just be able to cure cancer. That seems to be an explanation that keeps being brought up. People keep saying, oh, just check out Dr. Seyfried's work. I don't think people understand that Dr. Seyfried's work, it's not just like, it's not like the establishment is just like, oh yeah, screw that guy. There are legitimate, many studies that show convincing evidence of the mutation burden being a causative factor for cancer. That I will say that when I looked at Dr. Seyfried's work, I also found some really credible and great research indicating that he had some great points. So in my video at the time, I kind of fell in between and I said, well, why couldn't it be both? Why couldn't we have kind of a hybrid model that indicates that for some cancers, yeah, there's defunct mitochondria, and we could be able to target those and effectively really inhibit and damage those and kill those types of cancer, while on the other side we still also have other cancers that aren't as susceptible to just metabolic reprogramming, that they're able to kind of shift from glucose to fat, or maybe they're predominantly in fat metabolism or whatever it might be. So I just don't think that it's quite as simplistic as to just say, just eat a ketogenic diet or fast, get your beta hydroxybutyrate levels, which is the main ketone that we discuss, and therefore you'll be able to kill all cancer cells. I understand the point that it goes to different, like you can get those ketones to different areas of the body more efficiently. That might be true. But I will say that there's other research as well that looks at butyrate outside of cancer. So looks at like endothelial cell health. And they do show in vivo research where if you increase butyrate levels, that it does pass into the bloodstream and that it has an effect on the entire vasculature, so your cardiovascular system, and it tends to improve your cardiovascular system. So to say that we can't get enough butyrate to have to create a biological difference just doesn't really bear out in the literature. We have many different types of studies that indicate otherwise. Not to mention, I'll also fall back on the idea that the main source of butyrate that we get, so one of the main sources, fiber, has been consistently linked in many, many, many studies. I'm talking hundreds and hundreds of thousands of participants shown to reduce cancer incidence and mortality, and just has an overall positive effect. So is that necessarily through butyrate? Well, we can't necessarily say that. I will concede that. But I also can't imagine that that doesn't have an effect, especially when we have so much evidence specifically pointing to butyrate having a positive effect. So probably a more lengthy conversation to be had there. I agree with certain points. I just don't agree with certain other points. But anyway, I still appreciate the commentary. And and I will say for the cancer research, for sure, there's plenty of in vivo research where they don't apply insulin to the cells. I don't know, like I shouldn't say I never. In one of my experiments that was never published, I applied insulin just to see what would happen. And nothing crazy happened. But in all of my experiments that were published and in other experiments that I did just kind of leading up, we never used insulin in any of my cell research. All right. We got about 3 more topics, and then I'd like to just go over some light housekeeping like I usually keep at the end of each podcast. So for the next topic, I had to discuss this because I discussed this earlier in the year. I did some work on seed oils and their impact on our health. I mostly focused on cardiovascular health, but I also touched on other aspects of health as well. So, seed oils and health. I think there's probably a number of different mechanisms that people discuss seed oils and how they affect our body and how they're, a negative force in our body. The 2 that I'm aware of, at least that have been discussed in the literature, discussed in the literature, but not exactly in the context of how it's discussed in the anti-seed oil world, is the oxidation of polyunsaturated fats. So seed oils are, examples are like soybean oil, corn oil, canola oil, safflower oil, sunflower oil. Those kinds of oils contain within them the dangerous component that a lot of people have talked about, linoleic acid, which is an omega-6 polyunsaturated fat. Basically, what that means is it's a fat molecule that has multiple kinks in it, and because of its structure, it is more easily oxidized, meaning that it's more easily damaged in a manner of speaking. So that's one aspect. The other aspect is, and then of course, if it's integrated into your cell, so think of like into your cell membrane, into the membrane of your organelles, like the different structures, think like the mitochondria, and think of the endoplasmic reticulum, the Golgi apparatus, that then you could potentially get this accumulation of these damaged fat molecules within the structure of your cells, which obviously that doesn't seem like a very positive thing. The other thing is that omega-6s can be pro-inflammatory. Again, these are the mechanisms that have been mentioned, that omega-6s can be pro-inflammatory in that they get converted to what's known as arachidonic acid, and that arachidonic acid can have significant negative effects within the cell. And technically, arachidonic acid is then converted or can be converted to different other pro-inflammatory molecules. I believe like prostaglandins. eicosanoids, and there's a bunch of other ones as well. But ultimately, these pro-inflammatory molecules then can get secreted out of the cell and can lead to more of an immune reaction and damage the surrounding environment and things of that nature. So those are some of the mechanisms that have been brought up. I'm sure that there are others that have probably been brought up in kind of the depths of the internet that I'm not aware of. And that's perfectly fair. I'm not here to really discuss the mechanisms as much as I am to discuss the clinical data, because ultimately the clinical data is always going to trump any sort of mechanistic research. So, and I'm actually going to come back to that point on our final topic as well, because I think that's going to be important. Okay, so looking at the clinical data, I pulled together a whole lot of studies. In total, I didn't necessarily open up every single one of these studies, but I opened up a lot of different analyses, including some isolated studies. And across something like 200 studies, maybe 150 studies that looked at, in some capacity, omega-6s, again, that's these polyunsaturated fats, and their impact on our primarily cardiovascular health. But again, I did dabble in some of the other metrics, outcomes as well. It showed pretty reliably that there was either a neutral effect or a slight positive effect of consuming omega-6 fats. Now, there is one research group that seems to believe differently from many other research groups, especially one research group headed by a prominent researcher known as Bill Harris. This one research group, the Ramsden group, ended up doing an analysis that I thought was quite interesting, where they split omega-6 consumption, the studies that just looked at omega-6 consumption versus a control group, versus the studies that looked at omega-6 plus omega-3 versus a control. And they showed that if you just looked at the studies that gave people omega-6 fats to consume, that they tended to have more cardiovascular disease. But if you looked at the studies that used omega-6 plus omega-3, they did not show that link anymore. So then the main point there, that the omega-6s may be a negative if omega-3s are not in the conversation as well. Now, I did have some negative things to say about the details of their analysis that I'm not going to rehash here. I think that they missed the boat, or they left out certain details and didn't do proper analysis on some of the data that once you open up the studies, you realize, oh, well, I don't know why they didn't include this, or why they didn't, account for that, or whatever it might be. Again, for the details, check out the video. I'll have it linked for you. But there were several things I just didn't agree with their overall interpretation based off the data that was presented. Still, that doesn't mean that they didn't have a point. And in certain respects, I did agree with them on their overall point, like omega-6s, like the relationship between omega-6s and omega-3s. There were some other analyses that I didn't think were that great. I think that overall there just isn't a whole lot of data from randomized controlled trials that look at omega-6 consumption versus, particular, like saturated fats or some other condition. There are some old studies, like most of them are from like the 60s, 70s, all the way up to maybe the 80s and 90s. But a lot of these studies have so many flaws within them. Like in certain respects, they have strengths to them, but in other respects, they have a lot of flaws to them. Again, check out the video on all that. It's like a 25-minute video where I go into a lot more of this stuff. And there's even more to say than what I went over in the video. But ultimately, like basing any sort of strong conclusion based on just that data is not going to lead you to anywhere really. And my conclusion was that, and it's, I think, largely true, that the studies showed either a neutral effect or and there were studies that showed a negative effect, to be clear. But again, if you look at some of the methodology of those studies, you start to realize, oh, well, there's a lot wrong with these studies. Like these in the modern day, like if today a study was tried to be published in a reputable journal, they probably would not be able to be published. It just, the peer reviewers would be like, this is insane. You lost 80% of your participants. How are you going to publish this? Or at least if we publish it, you're going to have to put in a lot of explanation for why you lost 80% of your participants, or there's potential strong likelihood of inclusion of trans fats. There was a lot of mixture between the control group and the intervention group. Like there's all kinds of different problems. So that's why I'm saying it's really hard to sit there and look at these studies that were done such a long time ago, and knowing the information that we know now, try to say that those studies are a good representation of seed oils or anti-seed oils. So I can't really go either way, for seed oils or anti-seed oils based on those studies. And when you do meta-analyses looking at all the different studies, even those meta-analyses, I mean, largely they show a neutral effect, as in no benefit, no negative effects. But even those, there's flaws simply because of the data sets that they have to rely on to create their conclusions. So then, to take it a step further, I decided to look at what other studies have been done. So I'm looking at like huge, large-scale epidemiological evidence, and looking at different controls that they do, they try to control for different factors. They'll try to do subgroup analyses. There was one that was really great where they not only looked at omega-6s, but also looked at omega-3s. And not only did they look at they didn't look at the consumption, they actually looked at the blood measurements of omega-6s and omega-3s in the blood, as well as proxies for tissue. So what's actually integrated into the body. So aside from just in the blood, which is already pretty damning, but then on top of that, what's actually found in the tissue. And there they showed a really striking graph that as the omega-6 to omega-3 ratio, so that means the more omega-6, so omega-6 over omega-3, so taking both into consideration, if you have more omega-6 or reduced levels of omega-3, that there is an increased risk of cardiovascular disease, which goes back to what the Ramsden group was saying, that if you just up omega-6s, that you get worse outcomes. Now, again, that was based on old data that had a lot of flaws in it. But now, if we look at this epidemiological study that included tens of thousands of participants and used far more rigorous metrics of using blood measurements, they do show a kind of a similar story, that if you increase omega-6s in the blood to such a degree that the ratio is so much in favor of omega-6s over omega-3s, that you start to see this association with increased risk of cardiovascular disease. Okay, so that in itself is pretty alarming, and it's kind of scary. But if you look at the numbers, so the ratio, what they considered the ideal ratio, or what they compared everything against, was a ratio of 4. So for 4 units of omega-6s, you have 1 unit of omega-3. Okay, and then they scaled that, so as people had more and more and more and more omega-6s, so we're getting to 12, 15, 20 times the amount of omega-6s in the blood compared to omega-3s, they showed that the risk increased. Okay, so keeping that in mind, then they were like, well, what does the typical population consume? So we've got our ideal of 4 to 1, but what does the ideal population consume? And I think it was something like 8 to 1, 9 to 1, 10 to 1, something like that. So certainly more. But when you look at that same graph, it is still squarely in reduced risk. And really the best interpretation would be no reduced or no increased risk. So right there, neutral risk, as in no negative effects that are experienced from typical consumption. And keep in mind, this is typical consumption, which means that people in day-to-day living are consuming omega-6s, and the result is this association with no increased risk. So yes, we are talking about including people that are going for fast food. Yes, we are talking about people that are cooking at home. Yes, we're talking about people that are going out to fine dining establishments, that are eating junk food, it's tens of thousands of people. So we're including all these people. We're talking about heated seed oils. We're talking about cold seed oils. We're talking about all these situations because we have such a large data pool, and the result is that there is no relationship with increased cardiovascular disease. Now, let me take a step back from that. And I just said that we're looking at people, that go fine dining, that may be consuming omega-6s, that go fast food, all that stuff, that may be eating heated seed oils and cold seed oils. That doesn't mean that we have the granularity through subgroup analyses to find out if one group may be getting disastrous consequences from consuming seed oils, while another group is consuming seed oils and getting benefit from seed oils, and that's what's leading to a neutral effect. Hopefully that's clear. We're looking at big data sets. So we would need to do far more analysis on these different subgroups to tease out, is that neutral effect or that neutral association, is that still the case when we look at these different subgroups? Is it neutral for everyone, or is it maybe slightly elevated for some people and then slightly reduced for other people? Those answers were not provided in that study. But one other thing that they did, and I mentioned this in my insider analysis, that if they looked at just omega-3 consumption, or they just looked at omega-6 consumption as they did a standardized increase in, I guess I shouldn't say consumption, but the blood levels, as they did a standardized increase in blood levels of omega-3s and standardized increase in blood levels of omega-6s. So breaking the data apart, not looking at the ratio, but looking at just the amount found in the blood, they found that no matter what, there was either a neutral or reduced risk in the omega-6 group, and there was only a reduced risk in the omega-3 group. So when looking at omega-3s or looking at omega-6s separately. So that would indicate that the evidence is more leaning in the direction of omega-6s probably are not a negative to our health. Does that necessarily mean we have all the answers? No, because of what I just explained before. We don't have different subgroups. Now, in addition to that, I did do a separate analysis on canola oil, which is one of the ones that people are really fearful of for some reason. I did a poll, and people voted on canola oil being like the number one that they wanted me to look into. So I looked at canola oil and if it's inflammatory. So I pulled together every single study I could find, and I asked the community. I used the good old AIs out there to pull together every single study, every randomized control trial I could find on canola oil and inflammation. And I think I found 10. There are 10 studies currently that have been done on canola oil and looking at inflammation. I will be honest with you, most of these studies, the study quality is really bad. It's not very good, but based on all these studies, I think 9 of them showed either neutral or positive effects on inflammation, and that's compared against all kinds of different things. There was one study that showed, it wasn't a very good study as well, but still there was one study that showed that it may have a pro-inflammatory risk if it was heated over and over and over again. I think it was heated something like 20 times over and led to small increases in inflammation. So based off this one kind of poor quality study, there might be a signal there that if you constantly heat omega-6s, or we'll say canola oil, we'll restrict it to what we looked at, to canola oil, if you continuously heat it over and over, like, on a pan or whatever it might be, you continuously use it. So think like fast food. I think that's a great example. I don't know how the fast food industry works in terms of, I'm assuming they don't rotate out the oil after every single meal, right, that they make. It's probably just continuously heated over and over and over again, which is exactly what we're talking about here. So in that situation, there may be a small inflammatory risk. Keep in mind, we're not looking at cardiovascular disease in this situation anymore. So we're looking at kind of a softer metric, but still with that softer metric, we're seeing that there may be a negative effect. So is it possible that if you repeatedly heat these omega-6 unsaturated fats, keep in mind that's going to massively increase the amount of oxidation that occurs to them? Could that be a negative to our health? One single study looking at this is not enough for me to say end all be all. We are for sure, we need to cut away all seed oils or anything like that. And that wouldn't be a reasonable conclusion anyway, based off all the other data that I told you about. But my perspective currently is that omega-6s at the amounts that we're consuming them, even at really high amounts of consumption, just don't seem to be much of a risk, at least for cardiovascular disease, and it also seems to be the case for inflammation based on the evidence I've seen up to now. That could shift if you start to add in other variables like the heating process, or we don't even know if heating, if you cook with it once, who's going to sit there and save the oil and then cook with it again, and then save the oil and then cook with it again? That's really only in kind of a fast food situation or a restaurant situation. So is that applicable to how you cook? Probably not. So I don't even know if we can extend that to one time, cooking with it one time, and if that's going to have a negative effect. I can't even speculate. I don't know which direction that would go. The only thing we know is if you cook with it 20 times over, then there is a potential for a negative effect. So you can kind of see where I'm going with this. The overall point for me is that omega-6s seem to be at least neutral for our health, and likely in certain instances slightly positive for our health. Omega-3s seem to be robustly, continuously positive for our health. So if you're really afraid of it, just don't worry about your omega-6s as much, and then increase your omega-3s a little bit. And then you'll fall right in line with what the research indicates, that you'll see positive effects on your health. And there's a lot of nuance to that as well, because, if you're over-consuming all this stuff and you're gaining weight, well, hold on, we got to back off, and we can't say then, oh, well, Nick is misleading us because omega-6s made me, gain weight, or I had a heart attack when I started consuming more omega-6s. It's like, well, hold on, you also gained 30 pounds. So is it the omega-6s or is it the weight gain? That's what I'm saying. There's a lot of nuances that on an individual level you would have to figure out. But on the broad strokes, that's what I'm saying, is that typically there's a neutral to slightly improvement in health from omega-6s, and omega-3s, there seems to be a consistent improvement in health. We don't know about subgroups. We still need to look into that in more depth. I'm trying to communicate this as intellectually honest as possible. I'm sure I'll get called some seed oil shill by any number of different people. That's fine. But that's really where I ended up landing. based off of my video, and I would certainly recommend that you check out the video, because I do a far more succinct job of explaining everything I just went over. Okay, let's get into a few comments here. Okitasuji says, what I find curious is why all seed oils are lumped together, considering their fatty acid composition is quite different. So what Oki is talking about here is that I'd mentioned that there's soybean, corn, canola, safflower, sunflower oils, etc. And it's true that each one of those has a different composition. Like canola is pretty different from the others, and yet people seem to be most fearful of canola. But then if you were to look at some of these others, there's some more similarity, but there's still differences in the type of fat molecule that's found. So just because we're talking about omega-6s, there are different types of omega-6s as well. I think the main one that people are afraid of is linoleic acid. So it's true, we're lumping all seed oils together, and it kind of speaks to kind of the imprecision of how this is being, talked about. And if I had it my way, I would break each seed oil apart. I would break each fatty acid apart, the percentages of each, the absolute amounts of each. I would look at different outcomes for each: inflammation, cardiovascular disease, cancer, diabetes risk, all these different things. I would look at subgroups. I would look at which ones have been heated, which ones are cold, like all that information, which would, it'd only take me about a year or 2 years worth of work. And in addition to that, we don't have some of that data. So it's a great point. It's just, unfortunately, again, in the social media landscape, people just love to oversimplify, which leads to a lot of, I think, just in general, bad takes. Another question from Tropius, or not question, comment. My main takeaway: even if seed oils are bad, the effect size is so hard to find and easily confounded that I'm probably reducing my lifespan just stressing about it. Yeah, that's true. People are so focused on seed oils that they're kind of missing the forest for the trees. I think I nailed that one. Focusing on so many other things is going to have a far greater impact on your life and your longevity, your health span, than focusing on seed oils, especially based off the literature that we have at this point. Another comment, Water Balloon Fighter. Thank you so much for this and for highlighting the importance of what are you replacing X nutrient with. As a dietitian, that's always something I'm keen on asking patients. Not sure if you remember, since you have many subscribers, but I recently commented that your work was part of my inspiration to apply for a Master's of Science in Health Statistics, and I just got accepted. So I did comment under this one. I just want to say again, congratulations. I mean, that's really awesome. I think statistics is just such an incredible field. I've always hated math. I've hated math. I hate math. But that said, statistics for some reason is just like conceptually is just something that I understand far better than the actual mathematical formulas. And I think statistics is just such an incredible field. I think it's often misaligned, malaligned, maligned. There we go. Woo! Got to the word eventually. English is also a struggle at the moment. It's an area that's often maligned. People will say kind of pithy comments like, you can massage the data however you want. Any number of different things. I can't think of them off the top of my head. I'm not the quickest on my feet, but to me, I think it's just an area that if you can understand it, you can have a lot of respect for it, and it will help you a lot in understanding a lot of the world around you, and what are the odds of something happening, or especially since you're going into, you said, health statistics, you'll be able to learn a lot more about the epidemiology. You'll be able to understand more about biostatistics, looking at, when you should be using proper statistical analyses like t-tests or a student t-test, one-way t-test, two-way t-tests, looking at ANOVAs, Bonferroni adjustments. Like there's all these different things that you learn about, and they make a big difference, because once you start reading studies, you're like, oh man, I see why they did this statistical test, because if they'd used this other more common method, it would have given them a potentially faulty conclusion. Or you'll read a study and you're like, ooh, man, it's so, like, the study is so well designed, but unfortunately they used the wrong statistical test, which really makes the conclusion of the study basically null and void. So as you delve into that world, it really gives you a greater appreciation for study design and yeah, just health in general. So yeah, congrats. And you already being a dietitian and then adding health statistics on top of that, it's going to be a potent combination. I think I've taken 4 statistics courses, I think 2 in undergrad, and then, maybe 5 or 6 even. And then I've taken multiple in grad school, and I still have so much more to learn. It's a huge field. I'm never going to be at the level that you probably will be, as getting your master's in biostatistician, being a biostatistician and whatnot. But it's an incredible field. Anyway, I won't bore people with it anymore, but I just want to say congrats. That really is a huge thing. In terms of what are you replacing X nutrient with? Yeah, that's a big thing too. I think one point that I was trying to make in my analysis is, like, we have so much evidence implicating, for example, like saturated fats, and especially trans fats, as being a negative for our health. Saturated fat, I'm talking about an umbrella term. There's many subcategories of saturated fat that, some are actually beneficial for our health, some are negative for our health, but I'm talking about the negative ones. So if you were to replace these seed oils with this narrative that seed oils are killing us, all this stuff, and then you replace that with like trans fats, well, regardless of what you think about seed oils, you have just massively increased your risk of death by switching over to trans fat. So what are you substituting a particular food for, or a particular type of food for? That is an incredibly important question in the real world. You know this, right? As a dietitian, you know this better than I do as a dietitian, that it can have massive impact on your life. So we shouldn't get so caught up in the kind of the social media sphere and world where people are just scaring you with kind of nonsense. I mean, like a lot of this stuff, they just they often don't cite studies, or they'll cite a single study, but then if you go into like ChatGPT, or you go into like any of these AI systems, don't necessarily ask them, are seed oils good for me? Because they're going to come back, and then if you have the mentality of like the establishment, they've indoctrinated the doctors and all that stuff, that's fine. But ask a question like, list all the seed oil studies that have been done, or list the ones that have been done in the last 5 years, and then look at, like, I'm not saying that this is the only barometer, because really you should have somebody that's like going to go through all these studies, but look at the conclusion for most of these studies, and you'll be surprised. I mean, how many studies just consistently show positive or at least neutral effects of seed oil consumption, or omega-6 consumption, linoleic acid consumption. And then you go to these fear-mongering like social media platforms, and you have to ask yourself at a certain point, why are they not covering any of these studies? Why are they're so adamant that omega-6s and seed oils in general are so negative for our health, but then you will find 20, 30, 50, 100 studies from all these different seed oils, and the vast majority of them say positive effects from all different types of labs across different countries, different funding agencies, all that stuff. It just kind of has to hit you and think like, why are they saying that exactly? Like, can I trust these people if they're not going to address? I understand them not knowing about a particular study or even particular 2 or 3 studies. I'm not talking about that. I'm talking about the vast majority of the studies indicate no harm. So anyway, I'm kind of going off on a tangent there, but something I just wanted to point out. But again, just want to say congrats. And yes, as a listener, you should be thinking about, what am I going to be substituting my omega-6 with if I want to avoid omega-6s? What am I going to substitute that with? Is it more protein? Okay, that might be good. Would it be a fibrous carbohydrate? Okay, that might be good. Is it potentially more palmitic acid-filled saturated fat, or is it trans fat? That's probably not a good idea. So you should always think about what you're going to be substituting it for. All right, the second to last topic that I wanted to cover is the ineffectiveness of creatine. Dun, dun, dun. I've done so many videos, and I plan on doing so many more on creatine because there's so much research that's been done on creatine. But there's this one study that came out from some pretty reputable researchers that social media, I shouldn't say social media, I actually saw media covering this, saying that, actually let me backtrack real quick. Social media largely said that creatine was still beneficial after this study. So this study essentially says that creatine is ineffective. And I'll explain what that means in just a little bit. But social media went in on this study and said, no, they messed all this stuff up, which they did mess up some things. I'm going to go over it in just a second. But I always find it funny that once we've kind of globbed on, we've attached ourselves to something, creatine is beneficial, which I am definitely in that camp. But it's almost like it's like our preconceived notion immediately when we get hit with a study that says something different, the only thing we focus on is what are the negatives of that study, as if there's no way that we shouldn't be like trying to integrate this study with what the broader literature has to say. The only thing we do is just go in on that study. It's like you go in angry already. It's like going into a conversation angry as opposed to going into a conversation with, okay, let me ask questions first before I start accusing. And in social media, creatine is kind of elevated up to this point of like it's untouchable. So all the videos I saw, they weren't even necessarily critical analyses of like the study design and whatnot. They were just like, this study is just like BS. Like, they're talking nonsense. It was like this preconceived notion of like, we've accepted creatine into our ranks, therefore everything against it is just nonsense, which is tough to fight against, but it's definitely something that we all have to kind of be aware of, definitely myself included. Anyway, so beside that, there's this creatine study that released several months ago at this point, and they were looking at lean mass. So creatine has been known that if you consume it, that it increases lean mass. It's been shown across a whole host of different studies. But what this study did that was unique was they had participants load with creatine. So they took creatine and they were compared against the placebo group, but they took their lean mass measurements by a DEXA scan before they took creatine. Then they took another DEXA scan 7 days later after they'd loaded with creatine. They'd been consuming creatine for 7 days. And then they underwent a resistance training program for 12 weeks after that. And then they compared against the placebo group that also underwent a resistance training program for 12 weeks. And then they measured their lean body mass again. And what they showed is that, yes, their lean body mass was increased at the end of 12 weeks. But if you subtracted the initial 7 days, so after the first 7 days of creatine loading, if you took that added lean mass that they gained from the creatine supplementation, because creatine leads to water weight gain, there was a nullified effect of the lean mass gain, meaning, in simple terms, that the creatine, the only thing it was doing was increasing water weight, and that all the previous research was faulty because they had falsely assumed that the increases in lean mass at the end of all their studies was because creatine was leading to greater muscle growth. Okay, so in one way, this study was really, I liked it. It was very simple design. I really appreciated the fact that they did this style where they didn't actually start resistance training until after the first 7 days of loading with the placebo or the creatine. And then the fact that they're able to tell the difference between the creatine at the end and the creatine after the 7 days to try to tease out those differences, and found, oh, there's no difference. All the gain over those 12 weeks is not from anything that happened over those 12 weeks. It's from the first 7 days, the water weight. So that is definitely, on the surface, it seems like a pretty damning study. And it's not that the other studies were like, I don't know, mischievous in any way or anything like that. They just had an error in their methodology. But the real thing is, did they really? And here's where I came back with some critiques of this new study's design. One major critique that I had is that they actually clamped the volume. So from the weight lifted. So over those 12 weeks, the resistance training was the exact same between the placebo and the creatine. Now, if you know anything about creatine, you know the creatine mechanism of action is that it increases the energy available to continue to lift weights. So if you are clamped at the amount of weight that you can lift throughout that 12 weeks, so the volume, the total amount of work done is the same, then you are, and this is a major issue in epidemiology, as in not a major issue as in like many studies suffer from this, but they're very aware of this problem. You are removing the main benefit of creatine and then saying, look, creatine doesn't work. So what would be a better design is to not keep the volume the same, but to allow the creatine group to, if they were to get this benefit of added volume just because they can do more added volume, then measure if they see any improvements in lean mass. And I think, and it's not just that I think, this is just like some bias, like because I'm a big fan of creatine, I'm going to defend creatine. There's also an aspect of, there are other studies that have done that, and they have shown that if you increase the volume, sure enough, creatine leads to actual muscle gain over the placebo group. Now, in addition to that, there are studies that have not looked at lean mass and looked at a far more specific, far more targeted measure of the actual proteins within the muscle. So the problem with lean mass is that you're measuring, yes, muscle mass, but you're also measuring bone mass and you're measuring cartilage or connective tissue. And it's not to say that bone mass is going to change over, 12 weeks, 16 weeks, or whatever it might be. Even, 3 months, 3 months, 12 weeks, like 6 months, it probably wouldn't change any appreciable amount. But what might change is like their cartilage or whatever it might be. Would it be enough to account for everything that we saw? Probably not. But is lean mass sensitive enough to pick up small differences between the placebo group and the creatine group, especially when you clamp the amount of volume? But even if we take that aside, the answer is potentially not. So we don't know the answer to that, but what we do know is that there are studies that have just foregone the lean mass and looked at the actual protein, so the actual myosin and the actin protein. So these are the actual filamental proteins that allow your musculature to move. They actually ratchet back and forth. It's an incredible process. You can look up cross-bridge cycling and you'll learn how incredible it is. But anyway, when studies look at those, they show pretty substantial increases in those proteins from just creatine supplementation. So yes, creatine has a direct effect on the musculature. Yes, it does fill it with water as well. So that is well known, no debating that. But this study, while it was illuminating in one regard, and it kind of set off yellow flags of like, hey, in the future, maybe when we look at lean mass, we should measure after the initial 7 days of creatine supplementation, which I think is a great contribution to the field. But on the other hand, is it damnation of creatine? No. And my creatine sponsor would be pissed if I said yes. I'm just kidding. So I still remain obviously incredibly bullish about creatine. Again, it's a supplement. Is it going to change a person's world? Maybe if they have some sort of creatine deficiency or something like that. But like for the vast majority of people, it's just going to be a small benefit, just like any other supplement that's out there. As far as I'm aware, I like creatine simply because it has an effect on the brain, has an effect on performance, has an effect on our musculature, has an effect on a number of different areas, sleep, and there's even more research coming out that I'll get into in the future. So is it a debunking of creatine? No, it's more of a cautionary tale, and I think it's a good one to have, but it doesn't negate any of the far more specific, far more nuanced research that's been done out there that people just aren't aware of. So anyway, wanted to throw that out there just because I thought it was fascinating. Okay, so some comments. Yeah, I actually wanted to add this. This is one of my comments. I said, just as a fun aside, for those that put up unending emphasis on who funded the study, so this study that showed that creatine was ineffective, one of the main researchers of the study has a sponsorship with a creatine producing company, and yet they still publish a study against creatine. And this is not the first time that I've seen this. Actually, multiple times I've seen when I look at the funding source, and it's by somebody who is funded by like a creatine company, or there's one that was on Tongat Ali, I think. And the study was actually maybe even performed by a Tongat Ali company, and they published results that showed that there was no effect. Now, is that like a constant thing, a common thing? No, it's not. And that's why we need systems like what's known as clinicaltrials.gov, which forces researchers to pre-register what they're going to measure and then to submit their data regardless of if they publish or if they don't publish. And clinicaltrials.gov is just a fantastic website. So I thought that was, it's still funny though, like when, people get so strung up on, just got to focus on funding. If the funding is wrong, then I'm just dismissing the study. When there are many instances, probably not as many as there probably should be, but there are many instances where the funding source actually would be very unhappy with the results of the study, and the study still gets published. Because, and I've had these conversations with some of my my PIs in the past, my mentors in the past, but during my grad school. But there are contracts, and the university also oversees some of the, at least the people I've spoken to. The university oversees the contracts that are written out, and it's often written in such a language that regardless of the results, I will publish the results. So once you give me the money, I will conduct the study and I will publish the study as is. So regardless of if it's positive or negative, and that happens quite often. So at least, again, not necessarily something I've done, but it's from insight from some of the researchers that I've spoken to. Okay, anyway, back on topic. Pac-Man Fanable said, more creatine for me and anyone else who's been using it. This study is the best way to keep the cost down and the supply up. Yeah, well, there you go. That's true. Just tell people it doesn't work and then just see the prices drop and then buy it all for yourself. Two more comments. I did add this one too. Howard Davies, which did get promoted near the top 2, which I'm very thankful for. So thank you. This next topic, stopping by to commend Nick on the Insiders program. This is kind of a self-promotion at this point, but I promise it did get a bunch of likes and got to the top, near the top. Commend Nick on the Insiders program and its separation from the main channel. I don't feel like I'm missing out on not subscribing to the Insiders. That is to say, I don't feel like I'm getting screwed into signing up. I also think that the adverts have been integrated really well into all the videos. The script of if you'd like more detail, you can find it here with the other benefits isn't intrusive and it gets the point across. I hope it's worked well and generating the revenue to support the main channel. Thanks for the quality content. Howard, I really appreciate it. I know you're probably not listening to this, but it's kind of an off chance. But yeah, that was kind of the goal. I don't want... I'm not a huge fan of advertising, but I have to advertise in every single video. I mean, it sounds funny because I have to advertise the Insiders. It's just the way it is. It's literally the only way that I make money other than YouTube revenue. And I promise you, YouTube revenue is not paying in many of the bills. So yeah, it's really just the Insiders or bust. And I also don't want to get to a point where it's like I'm not helping people publicly in the public videos and whatnot. So I have to walk this fine line of like how much information I release. And I'm actually going to cover more at the end of this episode because I've got a few more things to say that I won't get into right now. But yeah, in the end, I deeply appreciate it. I added this definitely as a bit of self-promotion, but also to say thank you. It does mean a lot to me. When I get comments about the Insiders, it means especially more to me simply because I put so much work into improving the Insiders, and that's why we do these live sessions. And I do a podcast every month for the Insiders as well. And that's all because I'm getting feedback from people saying like, oh, can you do this? Can you do that? And I try to do within the means of what I have as a one-person operation. So anyway, I'll get off, go to the next topic, but thank you, Howard. I deeply appreciate it. Okay, Dave Chappell, not Dave Chappelle, but Dave Chappell said, I've been taking creatine on and off for decades. I've always known it doesn't grow muscle. However, I've always only gain muscle size when on it. The reason is that whenever on creatine, I work out harder and longer because I had more energy. The study you talked about has them doing this exact same program. So as in they equate the volume between the two. I don't know, but nobody ever told me creatine grew muscle mass. It was the effect on energy availability to go harder, which is my layman experience. Yeah, so you're exactly right, Dave. The primary mechanism that's brought up is that it increases the amount of phosphocreatine that's found inside your cells, which ultimately leads to more recycling of ATP when ATP is spent. So ATP being cellular energy. Okay, last topic here. Let me get into this. Non-nutritive sweeteners and cognitive decline. So this was one that I recently covered, and I wrote, I think the title was like, I'm starting to worry about artificial sweeteners. I use the word artificial, although it was about non-nutritive sweeteners, simply because I think people recognize the word artificial more than they recognize kind of a tongue-tying non-nutritive sweeteners. So, but it did apply to a number of different non-nutritive sweeteners. And the ultimate conclusion from this study, the result of this study, was that it was an associative study, and they were looking at a number of, I think like 8 different non-nutritive sweeteners, and they showed that there was an increase in cognitive decline, more rapid cognitive decline, if a person consumes more non-nutritive sweeteners as a whole compared to the group that consumed very little. Now, in addition to that, what I also mentioned, and they did do a bunch of, because this is associative, and I think it was over 8 years or something like that. It was several thousand participants, but it was prospective, so it wasn't a retrospective study, which is a weaker study design. This is a stronger study design, but it is still associative, and they do a bunch of adjustments for confounding variables. And among those confounding variables, they did address nutrition, and they addressed obesity, diabetes, cardiovascular disease, and a bunch of other potential reasons for why cognitive decline might be a factor. Now, that said, why I came to this conclusion of I'm starting to worry a little bit about non-nutritive sweeteners is, funny enough, I think I didn't emphasize this enough in my video, and I think some people, the majority of people got the idea, but some people didn't get what I was saying. They thought it was a little too extreme to say that you might worry about non-nutritive sweeteners. And the reason for that, it was not actually based on this study alone. It was the fact that when I looked at randomized controlled trials, so I looked at a lot of these different sweeteners, and I looked at randomized controlled trials looking at different cognitive outcomes. So looking at verbal fluency, or if that was like recall or some sort of memory task, or there's a back test, which is often used in cognitive recall testing. And I was just stunned at how little research exists. So I'm thinking to myself at this point, I'm like, wait. So we are deeming non-nutritive sweeteners as safe and fine for cognitive health, but we haven't actually tested it. And now, on top of that, we now have an associative study, which easily, just like any other associative study, could be flawed in some way that we just don't know. Like they didn't adjust for a particular something that we're just not thinking of. Completely possible. I'm not saying that we should base things just on this one associative study. This is it. We're done with non-nutritive sweeteners. I still consume them. My point being that there's such a lack of evidence that I think it's perfectly reasonable for a person to be like, wait a second. I was under the impression that we had all this research actually proving that they were safe for my brain. But now I'm realizing there's almost, for some of them, there's zero studies, no randomized controlled trials indicating safety for the brain. And now I'm supposed to just be like, well, I'm just going to continue to consume them as if I have all this evidence to back it. No, so then it becomes more of a question of what is your risk tolerance rather than, yes, I have all this evidence and I'm just going to ignore it and say that they're a negative for my health. And especially so the big two that I mentioned that had the greatest association was xylitol and erythritol. So both of these sugar alcohols. And it's funny because this isn't the only analysis. There's actually been multiple that I've covered that have also been associative, largely associative. And they've also identified erythritol and xylitol separately as being related to other negative health outcomes. So at this point now I'm thinking like, man, is it really fair to just keep saying that non-nutritive sweeteners we know, the key word there, know that they are safe to consume for our brain? I don't think we can jump to that conclusion. I would challenge someone and be like, well, okay, show me the evidence. It might turn out to be the case that we will get randomized control trials that do indicate a benefit. And to be clear, the other outcomes that have been tested, like for example, improvements in like insulin resistance or improvements in body weight, body fat, think body composition as a whole, yeah, no doubt. Like we have many randomized control trials and they all indicate benefits of non-nutritive sweeteners. I do have a few quibbles about sucralose because that one has a lot of mixed literature, but which I think I covered like 2 years ago. But for many of the others, it's typically, and even sucralose is going to lead to more weight loss and fat loss, which is a net positive. I'm not here to like ring the bell and say, oh, we're definitely, this is doomsday, stop all non-nutritive sweeteners. I will again say I consume them. I still consume them. But when I communicate that to other people, I'm not going to sit here and say, like for example, with the fat loss, I can point to many randomized controlled trials and say, look, we have the evidence indicating it is perfectly safe and very effective for weight loss and fat loss. And if you want to use it for that, like you're good to go. However, if a person says, hey, I'm having a tough time thinking, like I feel kind of brain fog and whatnot. And then they ask me, hey, what about non-nutritive sweeteners? Can I still take them and whatnot? One, I'm not their physician, but like if they just wanted my opinion, I would be like, I couldn't sit there and point to a bunch of evidence saying, yeah, they're perfectly fine. I would have to like sit down with them, have a conversation and be like, look, we don't have very many studies on that topic. We have one associative study that shows that there's a more rapid decline. There are some issues with that analysis, but they're not huge as far as I can tell, and maybe an epidemiologist might be able to correct me. They did do sizable adjustments for a lot of it. The greatest risk was for people that are insulin resistant, that have diabetes. There was far less risk, almost no risk for people that don't have diabetes and don't have insulin resistance. And even in the worst case scenario, it's not like I'm sitting here thinking that non-nutritive sweeteners are the cause of cognitive decline. Absolutely not. I think that they're a minor factor, but my job is to look at the research and analyze, is there an effect or is there not effect? If there is an effect, how much of an effect? And I think the answer is there could be an effect, and the effect is probably small regardless. Even if there is an effect, it's probably pretty small. So that was really the idea for why I'm worried. It's because I don't know about you, but I like to have actual hard evidence indicating, yes, it's perfectly healthy. Like there are plenty of mechanistic studies that show cytotoxicity of applying non-nutritive sweeteners, a wide variety of them, to cells, leading to death of those cells. And to be clear, obviously this is mechanism research, and you're applying such astronomically high concentrations to the cells that unless you have proper controls there, it's kind of hard to say, oh yeah, this is biologically relevant. It's probably not, especially at those doses, because the amount that's in the bloodstream is far lower than what's found in these cell studies. But now we're not just basing it on the cell studies. Now we have the first associative study looking at cognitive decline. It is a prospective study. They did a number of different adjustments that I thought were really, really great. They looked at the dose consumption that's up like about the amount of 1 can of soda or 2 cans of soda, which was like the highest level of consumption that they measured. And then we have a lack of randomized controlled trials, not for all the non-nutritive sweeteners, but for many of them, to look at something that I think is perfectly reasonable to look at, like cognitive outcomes. Like we should be able to just like apply it acutely, just a single dose, and then measure what happens. Like, does a person's like memory get impacted somehow? And then have other studies that last like 12 weeks of continuous consumption at the dose that they were using, that they were looking at for the associative study, like maybe 2 cans of soda or something, and then measure and see. And if those came back and said, hey, there's nothing to worry about, I would ease off a little bit more. I'd still be a little uncomfortable because the time scale of those studies is only several months, and the associative study is looking over 8 years. But it would still make me feel a lot better. And even now, even with this information that I know now, I'd still like to see more associative studies. I'd like to see more. I'd like to see some other labs approach this from different directions and see what they can come up with looking at different data sets. So, like if we were to look at like NHANES data and quantify, okay, do we see more cognitive decline? I don't think that they've actually measured cognitive, done different cognitive tasks. So I think that's probably not going to be possible. But if we were able to find some other data sets that also looked at cognitive outcomes like memory, verbal fluency and whatnot, executive function, which is these different brain outcomes, I mean, I'd be fascinated to know what other data is going to come out to find this link. So initially, my position went from non-nutritive sweeteners are perfectly safe. I'm not worried about them and I'll consume them at whatever quantity that I want. I went from that to non-nutritive sweeteners have not as much evidence as I would like, but I still don't think, and they have a little bit of evidence against them, but I still don't think that they're going to have a massive impact on your cognitive health, and I will still consume it. I still consume them in small to moderate doses. Not that I sit here and like just mass consume them in general, but whenever I could avoid it, like here I've got water, and sometimes I used to put non-nutritive sweeteners in here. Now I'll put like lemon juice or something like that, something pretty simple, or I'll just add nothing. And it's really just like small shifts like that. It's nothing crazy. You're not going to see a video from me, at least not based on this study, that's going to have me with a shocked expression and then it's going to be like, avoid all non-nutritive sweeteners from here on out. Unless, we get some randomized control trials that start saying, whoa, we have just detected an effect that we did not predict. That would be a big red flag. Right now, it's kind of like went from a dark green, solid green flag to a slightly lighter green flag, trying to go to yellow. It's not even at yellow yet. So that's kind of where I stand. Anyway, and your risk tolerance may be much lower than mine. And in that case, maybe you'll just cut them out if it's no, negative, if it's not going to impact your life in any meaningful way. I mean, not a big deal. Okay, let's get into, and I guess I'll say for the other side, and other people may just need way more evidence actually showing harm, not just a lack of evidence and this one associative study, but actual randomized controls trials showing harm before they'll even consider stopping non-nutritive sweeteners, which I think is a perfectly reasonable approach as well. Okay, number 69 said, I was part of a PhD's research into artificial sweeteners in a rodent model, chow and high-fat diet with never seen that before. I'll just say the one in parentheses, stevia is kind of the scientific name. I'm not sure if that's misspelled or not. Rebaudioside. Maybe that's correct. I just haven't seen it. So anyway, stevia and acesulfame K versus fructose and control. So histology of fat cells was unaffected by artificial sweeteners with normal and high-fat diet. No impact on offspring, weight, looking at influence in gestation, and no increase in inflammation. So TNF-alpha, interleukin-6. The literature is very mixed. The strongest potential effect might be on intestinal bacteria and the signaling pathways coming from that, but insulin and glucose tolerance was unaffected in our trials and nearly all papers. Okay, so There you go. So there's, and that's true. Again, I looked at some of this mechanistic research, and it's true that for some of the non-nutritive sweeteners, there doesn't seem to be much of a signal at all. So, and I can't remember all of them off the top of my head. I don't remember if I looked at stevia and acesulfame K, but here we're hearing that there is no effect. Of course, I can't vet this comment, so just be aware of that. But based on the literature I've seen, it has also been mixed. Some of it shows no effects, some of it shows negative effects when you're looking at the mechanistic research. And of course, this person is looking at fat cells, which, as we know from the impact that artificial sweeteners or non-nutritive sweeteners as a whole have on fat loss, that it tends to be very much a net positive. So would we expect to see anything on fat cells? I would say probably not, right? But would we? That's completely different from what we're looking at for neurons, right, in our brain, or microglia. So if you were to look at TNF alpha and interleukin 6 in microglia, which are the immune cells found in our brain, would we see an effect? I don't know. To be honest, and I can tell you from some of the literature that there are studies that show that there's an increase in or some negative effects. So again, mixed research. Tiago Zortea said, "To me, this study seems low quality too. Just the fact that they bundle up all the sweeteners into tiers based on milligram consumption instead of typical consumption seems to be a major red flag." So instead of doing zero consumption, 1 can, 2 cans or something like, or like maybe zero consumption, 1 to 2 cans, and then like 4 to 6 cans or something like that of diet soda, and then looked at the relationship. I think that's fair. I that was one of my critiques, that their brackets for the amount of milligram consumption was kind of all over the place. But on top of that, they had lumped all the artificial sweeteners into one category. So as in like aspartame, you'll consume like, I don't know, 120 milligrams, but then for like, I don't remember exactly the which one, so don't quote me on this, but like acesulfame K is like less than a milligram to get the level of sweetness that you would normally consume. So if that's the case, then you're lumping it all together and you're looking at 350 milligrams of artificial sweetener. That doesn't really tell you a whole lot about, what composition of that is made up from acesulfame K versus aspartame and whatnot. To be clear, they did break that apart, and that's in for some of their analyses, and they did identify erythritol and xylitol as consistently, even in non-insulin resistant individuals, having a relationship with more rapid cognitive decline. Also, I'm skeptical of their cognitive decline being a line instead of a curve that gets much stronger towards the 80s. Where is the control? So I think that may be, that is a good point. And typically you would expect, as one ages, that suddenly you would see a pretty rapid decline. To be honest, I'm not sure if they showed it I think what they were showing, if I had to explain it, is they were showing the rate of decline, although I guess that still wouldn't explain it. Either way, the data that they base their conclusions off of was a rate of decline per year. So it was a standardized measurement. It wasn't looking at the absolute change over the 8 years or whatever it might be, and looking at different age categories. So they had like 50, 60, 70, 80, and they had a line going down. It was perfectly straight. And I think that may just be the way that they were showing it. I'm not entirely sure. There's probably something there that I'm missing. So I can't fully explain that, to be honest with you. And where's the control? So the control is the low non-nutritive sweetener consumption. That's very typical in a lot of epidemiological studies. You're seldom going to find, maybe not for non-nutritive sweeteners, maybe you would find a large enough group that don't consume any whatsoever. but the low dose was very low. So it was like way less than a single can of soda. So they probably just from the amount they consume from, I don't know, on once a week, they maybe go to 7-Eleven or something and like they'll have like a Diet Mountain Dew. I don't know, like whatever it might be. But in general, they don't consume that much. So they're as close to zero as you can maybe get. In epidemiology, it's difficult to try to tease out those groups because those groups tend to be so far outside the normal. Again, that may not necessarily be the case for non-nutritive sweeteners specifically. But if you were to look at like, I don't know, we'll say people who consume less than 10 grams of saturated fat. Okay. Saturated fat, people try to reduce that in general, but like less than 10 grams, or let's say even more extreme, less than 5 grams, you really have to work at not consuming 5 grams of saturated fat. Like, unless maybe you're consuming a completely plant-based, but even plant-based, there are many saturated fats in like palm oil, for example, coconut oil, you know? So, and even olive oil has a little bit of saturated fat in it. So it's primarily monounsaturated, but like it's really hard to just like completely avoid these different fats. So, you know, finding enough people that would fit a control of like 0 saturated fat or 0 non-nutritive sweeteners or 0 meat consumption, that one's a little bit easier. But even then you'd have to look at a huge population just to get enough people into that sample to be able to compare everything against. And if you don't, the consequence is that you have so much uncertainty in the control that it creates a lot of uncertainty in the entire analysis because everything is being compared against it. The low non-nutritive sweeteners versus the control, high non-nutritive sweeteners versus the control, moderate non-nutritive sweeteners against the control. And if the control, the base of your analysis, is so uncertain, it renders the whole analysis extremely uncertain. So there's arguments either way, but that part I didn't find nearly as bad. Also, I find it very hard to believe that all these sweeteners with completely different chemical composition all cause the same decline. Yes, that's true. So that's a great point. And that's why like looking at the data just all lumped together can be off-putting and it can be misleading. So that's why they broke them up, and that's why I focused on specifically mentioning the main drivers were erythritol and xylitol. Also, too many factors being controlled dilutes the confidence in the results when the results are already mixed and you already have other problems. Yeah, so like controlling for different factors is always going to be a tough ask, and especially how you control it. So is it continuous or is it categorical? There's a lot of considerations. So that's why, again, I'm going to go back to my point that we'd probably need more associative studies, and then we'd probably also, I would actually like to see the randomized controlled trials before I really start to wave a red flag over here, you know. But yeah, great points, great pushback. Some other comments and questions people ask, like, was stevia assessed or sucralose assessed? The answer is no. I have done some separate stuff on sucralose and insulin resistance and blood sugar. I think my conclusion was that the evidence was quite mixed, and I would probably avoid sucralose if you are worried about like insulin resistance. I don't think it's going to like send you into diabetes or anything, but, you know, maybe has a really small effect at kind of pushing you towards that, simply because the studies that I found, all randomized controlled trials were, some of them showed either neutral effects, maybe like a few of them, if I remember, showed some positive effects, but there were several that showed negative effects. So, again, kind of in that, like, how much risk are you willing to take? Okay. That's where I'm going to leave things. We've been talking for almost 3 hours. I'm going to finish things off by doing a little bit of housekeeping. I keep this till the end, simply because I don't want to bore people that don't want to listen to this. But so when it comes to the videos, I want to talk about the videos a little bit, because Over this past like 6 months or so, I've been making subtle adjustments. Actually, since the beginning of the year, at the end of the year, I decided I'm going to start adding a main points section at the end of the videos, and that's because I was getting this constant feedback of like, well, can you give me like the short version of this? And I'm like, yeah, that's fair. You should be able to have everything kind of like put together for you on the highlight points of what's kind of the most important takeaways. And that's, speaking of takeaways, that's the other thing I wanted to work on. Make things that are more applicable, even if we go over mechanism research, to be able to integrate that with the clinical evidence and to say, okay, sure, this is fascinating mechanism research, but as always, we can't base things off of mechanisms. So we have to look for clinical research. And is there any clinical research? So I've been working on integrating both of those ideas together. And I did that for about 6 months, and it was working out okay, except I was getting a lot of new feedback telling me that the videos were too long and that people didn't need to hear a lot of what I was talking about. So this one was difficult because I was thinking to myself, I'm just such a nerd. I love talking about this stuff. And I know there are other people out there. Like, I also get feedback from people saying, hey, don't shorten the videos. So now I'm stuck between two groups of people. But the thing is, if I don't shorten the videos and if I don't cut away some of the fat, the juicy fat that's like I enjoy, but the juicy fat around the main parts of the content, the videos tend to not perform as well. Some of them will perform really well, and then the majority will perform not very well, and the channel just doesn't grow nearly as quickly as it probably should. So I've been trying to strike this balance of making punchy videos that have high applicability, high takeaway value with everything summarized, not everything, but like the main points summarized at the end, while still giving a flavor, a taste of that nerdiness, of the details. Like, there's some times where it's just like, I don't care what anybody thinks. I have to tell you about how butyrate interacts with your histone deacetylase. Just like real quick, give me like 1 minute to, I'm not going to bore you with the data necessarily, but I just have to quick mention it because it's just like, who wants to hear for the billionth time, fasting is good for your health, or eat protein to build muscle? Like, who gives a damn? We have heard that so many times. What people are here for, physionic, physio is based on physiology. It's like understanding how your body works. So being able to come to a video and not just understand what the clinical data says, but also be able to understand, like, why did that happen? Why did people, like, for example, with my FGF21 video that I did, why do people consume less protein and then they see this significant metabolism boost as a result? Like, why does that happen? And it comes down to this molecule FGF21. It's like, I don't want to just say, oh yeah, it's this molecule FGF21. No, it's like, well, how does it work? What's it secreted from? How does it bind to our receptors? Like, where is it binding? Why does it get released? Like, all these things. Like, there's so many questions and so many things we can dive into. And I don't want to lose that. Like, that's the heart of what makes Physionic special to me. I mean, it's just what makes me tick. I'd like to be able to take a person on a journey, the physiological journey, and have them feel satisfied that, wow, okay, I did not know that, you know, I can just tell you, oh yeah, a low protein diet will increase your metabolism. But like, that's not, I guess that's somewhat novel, but beyond that, you probably want to know, well, why? And how does that relate to the high protein diets that also seem to increase metabolism? Because the mechanisms by which they work are completely different. That's fascinating, right? So I don't want to completely eliminate that. Like, and that's never going to happen. I would just refuse to do that. So what I've done is I've tried to truncate the videos to make them punchier, like I said, have more takeaways, but also still fill in some of that physiological gap, some of the mechanisms and whatnot, without necessarily beating you over the head with the data. And then when I get into the really nitty gritty, I just save that for the insider content, which I know makes some people groan that I'm leaving things for the insiders and whatnot, but it's just, I'm legitimately trying to make the experience as good as possible, grow the channel as quickly as possible within ethical means, and also have enticing content for people that just want to learn more. And I really love being able to have these discussions with the insiders, which I do in these live sessions that I do with the podcast. I do a podcast every month for the insiders that goes over the month's content, all the takeaways. It lasts about an hour. It's much shorter than this drivel that I did today. But yeah, it's just like I need a place to be able to like really nerd out. And the other, so it's just it's kind of a necessity for me to cut the video length and keep them as informative and helpful as possible for people, while keeping the I think some of those intricacies and whatnot for the insiders. So for the insider versions of the video. So yeah, I'm just detailing you how I'm thinking about things. I'm still going to continue to make adjustments. Certain recommendations that people give me, like I can see it in my data. Like I go over my data analytics and whatnot on the back end, and some of the stuff that people have said for me to try, I'm like, I know that's not going to work because I can see it in the data. People don't respond to some people's suggestions. I can't even think of any off the top of my head, but yeah, anyway, the point is that for you, that just know that I'm constantly adapting. I'm trying to improve the content continuously. It's just slow going, and I'm tinkering here and there. I think this year was some pretty big changes. The whole main point section at the end, I think went over pretty well. And making sure that things are more takeaway driven instead of just this is fascinating, but like this is fascinating plus this is how you apply it. I think that's been a big thing for me too. Okay. I think last podcast I mentioned that I was going to be doing a self-correcting podcast idea. So the idea behind this, and I've been thinking about this entire time from last podcast up until right now. The idea behind this podcast was that I was going to have a guest, interview that guest at length about a topic or several topics, and then I was not going to publish that interview until I went into the literature, found studies to either corroborate or refute what that guest had said. And then I was going to have that guest come back on, and we were going to limit the discussion to just what we had just discussed. So filling in some of the nuances, but I was also going to push back against some of their takes based on like literature that I had found. So I'd probably send it to them and just let them know, hey, I'm going to be discussing this, and this, like this is, just so they're not like blindsided, because they would need an opportunity to look over that data and whatnot. So yeah, just have this more open format. So it's kind of a self-correcting. So then you would know, unless you don't trust me, which is, if that's your thing, then that's fair. I don't know how you got to this point of the podcast. You probably shouldn't be listening to me anyway. But assuming you trust me, then I would make it a far more open format, so people would know that the information that's being said is being vetted. So the first half of the podcast, it would be more free flowing, and the second half would be a lot more of this like digging deeper into the details while having all the evidence at hand. I love that idea. I really do. The problem is I can't do it. I have thought about it a lot, as I mentioned. it takes so much manpower. I mean, just so much manpower. It would take me so long to be able to release just a single episode. And I don't have that kind of time. And this is it. This is Physionic. You're looking at it. So I'm going to be editing this video. I do have some people that I work with on a part-time basis that like edit, the Physionic videos and whatnot. But beyond that, like I'm the ideation. I'm the one who creates like my rubrics. I do all the research. Like I do all that stuff. So for me to sit there for like a 2-hour episode or even a 1-hour episode and have a person talking at length, and I have to scrub through the video and I have to like figure out what they said, and then I have to find sources, and then I have to bring them back, and then it would take me months just for a single video. And honestly, I mean, it would be such a drain on me from an energy perspective, but also like monetarily. I think I would lose out on so much because I think I would end up resenting it just because I would feel like I couldn't pursue some of those nerdy details. Like all I want to do is read research, distill it, and put it out there for the world for people to understand what that research says, which is the whole idea behind Physionic. Learn your body. From the macro to the micro, if you know that line from years ago. And I just don't think that it's possible. If I had a team, which I don't want a team, I don't want a bunch of people, I don't want this to become like some massive company, then I would probably be able to do it. I'd be like the Diary of the CEO or whoever it might be, except fact-checked, and it would be a unique thing. I think that it's a great idea for someone to do, somebody with more capital, somebody with more time, somebody with a team of people that could sit there and sift through it and do the research, and then get the guests to come back on and have this whole process work out. It's just not feasible for me. I'm a one-man operation, mostly. So yeah, it's just not feasible, although I really love the idea. The other thing is too, like I've been thinking about just like the podcast in general, and I've already pulled away largely from having people on, and I think I'm going to completely nix anyone being on the podcast anymore. Not because I like to hear myself talk, but because I'm exactly afraid of that. I'm just kind of tired of people coming on podcasts and just kind of spewing their BS just everywhere, and people just lap it up, and we just don't have enough of like a fair critical mind of like, okay, this person said that, but is that actually true? Like there's no evidence with podcasts, right? Like, okay, I'll give like Dr. Rhonda Patrick some credit here. Like she'll put up the study title, like when a guest says something, she'll put up the study titled on the screen, which I think is really cool. The same with Gilles Carvalho. He does a great job because he'll put like reference number 6, and then you can go into the description and click on reference number 6 and whatnot, which I really like, but it's so much work. And again, for the vast majority of the time, it's just impossible. So I just don't think I'm going to have people on for the podcast specifically. What I am probably still going to do is have people on the channel. And what I'm going to do is so I'll have a small conversation with them in private, like a 30-minute recorded conversation on a very particular topic that they know a lot about. And then I will do kind of like a mini version of what I'm talking about, this like self-correcting thing, where I will then go and check after the references, and I'll do a fully edited episode, like a video that I usually do, and feature that person. But at least then that I've fact-checked everything they've said. Because I've taken the time, and it's a much smaller format. So I only have to fact check maybe 5 to 10 minutes of them talking, as opposed to a whole hour or 2 hours or whatever it might be. So I think that's the direction I'm going to go. And the podcast will just be me ranting on this couch. That's probably going to be a negative for a lot of people, but it's just the way it is. At least I know, with my notes and my hopefully not demented brain, that I will be able to just give more context and engage with the comments of what people post under some of the most, what I find the most interesting posts, which is what I did today in this episode. Let's see. I did mention the insiders, Physionic insiders. I'm going to mention it one more time. It's the only way that I support myself. Well, I do some consulting, but like largely this is the primary way that I support myself. If you like this kind of podcast, this was way more free flowing than what I do for the insiders. For the insiders, it's about an hour long, sometimes 45 minutes, sometimes like an hour and 15 minutes. And it's much punchier. So I go through every single investigation that releases for the insiders. And then I have a takeaway section at the very end. So I'm like, if this, then this, then that. So like I said, it's much punchier. And the whole goal is just to go over all that month's content in one episode. So if you're interested, check out the Physionic Insiders. It's linked in the description. No pressure, obviously. It releases once a month. You also get a private podcast link, so you can access it through Spotify or Apple Podcast or whatever, Stitcher, whatever you like to use. And you'll just get updated every month. It's not the first of every month. It's like the first 7 days or so of the month. But I have released an episode every month for the last year and a half. I'm very consistent with it. I never miss a month. And you also get a ton of other perks, like I've mentioned in all my videos. If you want to engage with live sessions with me, I do those. You also get articles. You can have those sent to your email, and a bunch of other stuff. I'm not going to bore you with all the details, but yeah. And the last thing I want to say, which I always want to finish with this, look, I always deeply appreciate anybody who's along for the Physionic journey. It's as simple as that. I'm a highly ambitious person, but I am also highly focused on the ethics of the business side of Physionic. And I'm constantly taking feedback and trying to improve wherever I can. There are limitations. Some things would just bankrupt me if I did them. And I also, like I said, I just don't want Physionic to be this have you ever, okay, let me put it to you this way. Have you ever followed a YouTuber or just a social media person? I hate calling myself a YouTuber, but I technically am on YouTube. Just like a social media person who's they started out small and then they grew and grew and grew. And then they started growing into welcome Chad to the team, and Barry to the team, and Natalie, and then they grow, and there's nothing wrong with growing, but then they grow to a point where it's everything becomes so polished, and so I think it's almost unintentional. They get into this position where they have no flexibility because they've taken on so many sponsorships, or they've taken on so many connections with people, or they've grown this thing that now they have to they've employed all these people, so they can't be as free as they were before. And I really think that's just because now they have so many people that depend on them for money, and which is a great thing. It's a beautiful thing to be able to build a business to the point where people are, depend on you, and you have all these employees, and you can foster a great environment for these people and a job, right? So that they can feed their families and all that good stuff. But there are downsides to that, right? And I know of many, over the many years of just been watching YouTube, I know of many examples of people that have grown and grown and grown, and then they just kind of lose sight of, I don't want to say necessarily the ethics, although sometimes it is the ethics, but just this sense of appreciation, just keeping things simple. I think that's my point, just keeping things simple. And as much as I'd like to undergo mitosis and like have different versions of myself, just like all working on all these different projects that I would love to do. I think that the best course of action is just to keep things small. I mean, obviously still grow as much as I can, but like not have this pressure of having all these people depend on me. Because I think on the front end, it allows me to be authentic. I kind of hate that word, but we'll use it anyway, to be authentic and to just have these conversations and not really care that much because I have wonderful people like you that support me. And it's just me, right? So I don't have to worry about like, hey, I need to be selling because I have to be paying all these other people behind me that are helping me throughout this thing, all these employees, because that's just not the case. So yeah, I mean, I realize I'm kind of like ranting and kind of thinking off the top of my head, but I just wanted to say thanks. It means the world to me. Physionic is my job. Like, that is crazy to me. And I'm going to continue to push it as far as I can. And it's not like it's going to stop. It's not like I'm going to suddenly be like, well, I've read all the studies, done. I got nothing else to say. That is not going to happen. There's too much. There's many lifetimes of content that I could produce and studies I could analyze and things I could learn. And I have another 30, 40, hopefully 50 years ahead of me. Man, knock on wood, that I can continue to do this. And yeah, it's all possible simply because people like you actually listen or watch or engage or make funny comments like Zappy. Yeah, I do know some of your YouTube comment names, and I do recognize them. Little Voice is another one that pops up. Cookie, definitely Cookie Cupcakes. Yeah, just like there's just like so many people that I could rattle off the names and just say thank you to. But in general, just like if you're listening to this, thank you. I really do appreciate it. Yeah, I can't promise when the next episode will be, but it'll release at some point. Physionic's not going anywhere. So until then, thanks for listening to me ramble about stuff. And yeah, have a great day. See ya.